Hello, hi, namaskar everyone. My name is Dipendra and I welcome you all in our session Relations and Functions Part 2. In this series where we are covering all your concepts of JEE in these one shots, Relations and Functions we have bifurcated into two parts. Good evening, namaskar. Hello, hi everyone. So we are getting started with this chapter Relations and Functions where in part 2 we'll cover the remaining portion, the remaining part of this. Shall we get started, everyone? I hope you all can hear me, see me, and listen to me properly. The stream right there in front of you is running smoothly. Just give me a quick confirmation so that without any delay, we can straight away get started. Shall we, everyone? So before I start, I hope you know one very basic fact that here, if you wish to participate in polls, which will be conducting while solving the questions, you can participate by using Pylons. So what is Pylons? Pylons is an amazing platform with which you can not only participate in the polls which we are conducting in these live lectures, but also with this Pylons, if you're watching any random video on YouTube, then you can generate PYQs, quizzes, short notes, mind maps, and a lot of things at absolutely no cost. I repeat, if you're watching any random video on YouTube, with this Pylons application, which you can download either from Google Play Store if you're watching it on phone, or from the Chrome Store if you're watching it on your application on your laptop or PC with the browser. Then with this Pylons, any random video if you watch on YouTube, you can generate not only PYQs or mind maps or short notes, but along with this, a lot of other things related to that any random video on YouTube. Shall I get started with today's discussion? Yes, it is indeed from basics, but the first part, we have covered a lot of details already. So this is the second part. So watch this second part right now. And after this session, you can go back and watch the first part as well, which already got released. Shall we get started, everyone? Here we are. So I hope you remember, before this, we have discussed a lot of other functions. Today, we'll start our discussion with polynomial function. Algebraic functions we were discussing, remember that? Yes. Great. No worries. You can definitely. With this, I am getting started with my conclusion on this polynomial function. I hope even degree, odd degree polynomials you remember. If I simply take an example here, I'll say if I take a polynomial function like this, if I take a polynomial function like this, f of x is given by, let's say, 3x square plus 5x plus 2. So this is a polynomial. Yes or no? Because it has certain inputs. Based on those inputs, output is getting generated, but they are creating a polynomial. Yes or no? And with this polynomial, I hope this is algebraic expression. The highest degree term is x square, which means the power here is 2, which means this is a polynomial of degree 2. Understandable, straightforward, direct definition. Good evening, hello, hi everyone. So I'm trying to tell you a very simple fact. Polynomial functions could be of either odd degree or even degree. Sir, why are we separating them or segregating them in two categories? The reason is pretty simple. When you deal with even degree polynomial, whenever you are dealing with even degree polynomials, their graphs can be drawn in a little different manner. And whenever, let's say there is one more polynomial gx, which is defined as 3x cube plus 7x square minus 6x plus 5. So this is again a polynomial. But here in this polynomial, what you all must be noticing is that highest degree term is 3, which means it is an odd degree polynomial. So sir, why are we separating them into two categories? Listen to me very carefully. It depends on this conclusion that, let's say, I am giving you 4 cases. Sir, which 4 cases? Let's talk about all those 4 cases one after another. Listen to me very carefully. I'm going to say something really important for you, which will be not only using in this chapter relations and functions, but that idea will be using in limits, continuity, differentiability, in application of derivatives, in definite integration, and in area under the curve as well. And up to an extent, if needed, definite integration as well. What is that property, sir? Polynomials, you'll be dealing a lot many times, not only here, but in 11th standard chapters as well. Theory of equations, I hope you remember. So there, if you, let's say, deal with something like this, a polynomial of degree even, for example, x to the power 4 I'm taking, where I'm writing it as 7x to the power 4 plus 6x cube plus, let's say, 2x square minus 7x minus 7. anything like that. You notice two things here. First thing, what is the degree of this polynomial? Let's say this is y is equal to something. The degree is 4. Degree is 4, which is even. And what is the coefficient of highest degree term? So that is 7, which is positive. Did you notice two things? Very crucial and important two things. For example, if I give you one more polynomial, like let's say 3x cube minus 7x square plus 4x plus 8. In this polynomial, again, definitely if you are in 11th standard also, you can watch it and you will understand it. Trust me. Again, tell me few things. Which few things, sir? Here, what is the degree here? Sir, the degree is odd. The degree is odd. And what is the coefficient of x cube? Sir, that's 3 plus 3. So it is clearly positive. Two more cases I'll bring, then I'll give you the conclusion I wish to talk about. Let's say one more polynomial I have, something like minus 2x square plus 7x plus 5. Here, what is the degree? Sir, degree is again even, yes or no? And what is the coefficient of x square? Sir, coefficient of x square is minus 2, which is clearly negative. One more polynomial I'll take to make it understandable. Y is equal to, let's say I'm taking one more case where I'm saying minus 6x, let's say odd, I have not taken 6x cube or power 5 you can take, let's say for a while, 6x to the power 5, then it can go somewhat like 7x to the power 4 plus 3x cube minus 9x square plus 8, let's say. So there it's having a degree odd. So I hope you are clearly noticing that, sir, here in this case, the degree of this polynomial is odd and the coefficient of the highest degree term is minus 6, which is negative. But sir, why are we really discussing all this? What is the point of discussing all this? Point is pretty simple here, students. Pay attention. If you ever deal with an even degree polynomial, then it will come from plus infinity and go back to plus infinity either, or it will come from minus infinity and go back to minus infinity again. So it depends on what? Depends on if, first of all, if it is even, it will come from positive infinity and go back to positive infinity corresponding to y-axis, or it will come from minus infinity and go back to minus infinity corresponding to the y-axis. First of all, this definition have you all understood or processed? Second conclusion, sir, plus infinity to plus infinity or minus infinity to minus infinity, how are we deciding it? This gets decided based on the coefficient of x to the power 4. So if the coefficient of x to the power 4 was positive, it will come from positive infinity. Let's say this could be y-axis. So it will come from positive infinity and it will go back to positivity after taking certain rotations. Now these curvatures, these movements will solely and totally dependent on its derivative. So AOD, differentiation, monotonicity, principle of maxima and minima, local maxima, local minima, that all we'll discuss in AOD. Right now, I'm just giving you a quick superficial overview of this concept. Everybody processed it. Now, along with this, let's say if I talk about this, what was the coefficient of this? So first of all, it was an even degree polynomial. So if it was an even degree polynomial, it would come either from plus infinity to go back to plus infinity, or it will come from minus infinity and would go back to minus infinity along with the y-axis. But sir, in this case, how are you predicting that it will come from minus infinity and go back to minus infinity? Because the coefficient of x square is negative. Getting my point, everyone? Yes or no? Let's extend it further. When we talk about odd degree polynomials, so odd degree polynomials will either come from minus infinity and go to plus infinity along with the y-axis, or they'll come from plus infinity and go to minus infinity along with the y-axis. Now, sir, again, either or, that also again depends solely on coefficient of the highest degree term. Sir, what did you just say? I said here coefficient of x cube was, coefficient of highest degree term was positive. So if it is positive, it will come from minus infinity and go to plus infinity like this. So this is how you will see the graph of an odd degree polynomial. This is the y-axis where it came from minus infinity and went to plus infinity. If you travel from negative infinity to plus infinity on x-axis. X-axis could be anywhere, that cannot be predicted because it depends on the solutions in the roots of this equation. The same would follow for the curvature as well. Again, if I talk about a polynomial of odd degree, so either from minus infinity to plus infinity or from plus infinity to minus infinity, sir, on what does it depend? It clearly depends on that what is the coefficient of the highest degree term, which means in this case, coefficient of highest degree term was positive. So it came from minus infinity and went till plus infinity. So if opposite happens, which means if the coefficient of the highest degree term is negative, in that case, what will happen? In that case, are you realizing? It will come from plus infinity and would go till minus infinity. And depending on the terms, so power 5, it could have 5 roots. It could have 5 roots, depending on that. I hope everybody is realizing and understanding that. So it will come from plus infinity and go till minus infinity along with the y-axis. And that's how you would see its graph or its approximate graph getting drawn. Now again, x-axis could be anywhere depending on its curvature and all, but yes, this is how. So I hope everybody is able to process it, yes or no. Everybody understood the concept of polynomials. Sir, why are you showing us these graphs? Because these graphs are majorly contributing in understanding the domain, range, and everything related to that. Let me try and cover that part. Here, if I ask you the domain here, so x-axis could be anywhere, x-axis could be here, or x-axis could be either here, or x-axis could be here, that I don't know. But wherever x-axis is, are you not noticing that this polynomial exists everywhere along with the x-axis? Which means what? Which means I will see the existence of this curve along with the x-axis everywhere. The same is happening here. You will see the curve to be existing everywhere along with the x-axis. You will see the curve to be existing everywhere along with the x-axis, and the same would happen here. So if the curve exists for all the points on the x-axis, what conclusion do you give? I will give the conclusion that this is for boards as well, Sanju. This is for boards and ITG both. Depends on how you utilize it. Coming back to this, I will say if the curves, polynomial functions exist for all the real values of x, can I not hold the position to conclude that's a domain of these polynomials, whatever they are, for 2 degree quadratic, for degree 3 cubic, for degree 4 biquadratic, for degree 5 pentic, and so on. Whatever degree of polynomial it is, they'll take all the real values. So if they take all the real values, I'll say their domain is all the real numbers. So for polynomial functions, if you wish to ask me its domain, I'll say it is all the real numbers. That is from minus infinity to plus infinity. Everybody got it? But sir, what about the range? I think you will come to a very amazing and a very astonishing conclusion when you talk in terms of range. Sir, what do you mean by that? Look at this. Whenever the degree was even, the polynomial attained a certain minima, and it went up till infinity. Or in that case, other case, the polynomial, whenever the degree was even, attained a certain maxima or went until infinity, minus infinity. Which means in case of even degree polynomial, something finite to infinity, its range would be, or something finite or minus infinity to something finite would be its range. And depending on what? Sir, if the degree is even, then the coefficient, if it is positive, its range will be something finite to infinity. And if the coefficient is negative, its range will be minus infinity to something finite. Unlike this, what happens with the odd degree polynomials is, whatever is the coefficient, are you not realizing, as I have already mentioned, that for these functions, I hope everybody is noticing, the graph exists from minus infinity to plus infinity. So what is the range? Range is going to be all the real numbers for odd degree polynomials. But here in this case, the graph, again, for any odd degree polynomial, whatever the coefficient is, positive or negative, its range is again going to be minus infinity to infinity. That's my point. Where I'm trying to give you this conclusion, please remember it as a fact that whenever you notice that there is a polynomial of odd degree, its range will be all the real numbers. Everybody digested this fact. Everybody processed this fact. Everybody understood this process, yes or no? Shall I move ahead from here, all the participants? Now, with this, let's talk about rational functions. If I could take a very simple example just to make you understand this, if there exists a function which has polynomial upon polynomial, I repeat, this is in the px upon qx form where q of x we cannot afford to keep as 0. For example, if it is given as x plus 3 upon x minus 2, of course, what will I say here? That x cannot be 2. So why? Because if x becomes 2, the denominator will become 0 and the expression will be not defined. So what did I just say? I concluded a very simple, straightforward, direct fact that this is something upon something form. So this is not a polynomial function. This is a rational function. It has a certain polynomial in the denominator, a certain polynomial in the denominator. Everybody understood it? That's how we define rational functions. I hope there is no query or confusion so far. Sir, what about quadratic? Quadratic can also be treated as functions, yes. So when I talk about quadratic, let's say a standard quadratic, I'm given ax square plus bx plus c. Now it totally depends on what is the coefficient of x square. So what do you mean by that? Look at this. First of all, the degree is 2, which means it is even. So it will be either something finite to infinity along with the y-axis or minus infinity to something finite. But sir, that whole story depends on what is the coefficient here, because it creates two cases here. Either a is positive or a is negative. I hope nobody is thinking that a can be 0. Because if a becomes 0, this wouldn't remain a quadratic, yes or no? In that case, it will become a linear. So what is your point, sir? My point is pretty simple here, students. If a is positive, it will be an upward facing parabola. And if a is negative, it will be a downward facing parabola, which you all must have studied in 11th standard theory of equations already. Sanju is asking, sir, can you tell me the session ends or take how many hours? Sanju, it's highly unpredictable, but still to give you some idea, minimum 4 to 5 hours or more than that. So you have to have patience. If you want relations and functions in one shot, we have already divided into 2 parts. This is the second part. So I'll try to culminate it around 5 to 6 hours. Try to. I'm not giving you assurance, but I'll try to. Here we are. I am giving you a very simple, straightforward fact that the moment a is positive, coefficient of x square is positive, it will be an upward facing parabola. And if coefficient of x square is negative, that means a is negative, it will be a downward facing parabola. What does it mean? It means along with the y-axis, it will go till infinity in terms of its maximum value, and it will have a certain minimum value. And this minimum value will be attained by you at this point minus b by 2a, comma, d by 4a. Did you all get it, or shall I repeat it, all the participants? I repeat this fact, which you all, sorry, it should be, I'm really sorry, I said d by 4a. No, it should be minus d by 4a. I repeat, listen to me very, very, very carefully, students. I am saying that if a is negative, if coefficient of x square is negative, in that case, it will be a downward facing parabola. So what happens in the downward facing parabola? It will go till minus infinity. The graph will keep going till minus infinity, but it will attain a certain maxima. It will attain a certain maximum value. Sir, what will be that maximum value? That maximum value will be this, and its point will be again given by minus b by 2a, comma, minus d by 4a. Sir, how are you bringing these points? There are 3 methods. Which 3 methods? One of the methods is using concept of derivatives that you must have been doing in physics. First derivative test, second derivative test. With first derivative test, you find critical points. So you'll find a critical point minus b by 2a. Then when you put minus b by 2a in this quadratic, you will receive minus d by 4a as the output. Now, sir, minus b by 2a could give me either minima or maxima. This is what you must have studied in physics, yes or no? So, sir, minus b by 2a is giving us minima or maxima. That depends on the second derivative test. So, if f double dash x at minus b by 2a comes out to be negative, it will be maxima. If f double dash x comes out to be positive at minus b by 2a, it will be minima. Remember that concept from physics. Sir, what if we don't use it? Another method, yes, converting it into a perfect square. To save your time, I've already done it. For example, if I'm given y is equals to ax square plus bx plus c. If I'm given y is equals to ax square plus bx plus c. So if I take a common and convert it into a perfect square, it gets converted into a parabola. What kind of parabola? I hope this parabola you must have studied in 11th standard, which is given by y is equals to 4ax square. Remember that parabola, students? This is a standard parabola, looks like this or this or this, depending on the coefficient here. Because if the coefficient of x square is positive, upward facing parabola. If coefficient of x square is negative, downward facing parabola. Remember that whole story. But sir, what if in that coordinate geometry, we have gone through something like this. Y minus k is equal to 4a x minus h whole square. In that case, what happens to the parabola? Again, please pay attention, everyone. The parabola could be either upward facing or downward facing. The parabola could be either upward facing or downward facing. Sir, the vertex of the parabola will be given by, do you remember h comma k? The vertex of the parabola will be given by h comma k. Do you remember that? But sir, the whole story again depends on one case that, sir, what is this 4a? 4 is positive. So if a is positive, it will be an upward facing parabola. If a is negative, it will be a downward facing parabola. Now, sir, where will you plot the y-axis and x-axis? That I don't know because I don't know h comma k. H comma k is the vertex. So depending on h comma k, y-axis and x-axis will be drawn. I'm just trying to give you that this is how a standard parabola is drawn in coordinate geometry. That same context if I bring here in this scenario. So by converting it into a perfect square, this quadratic equation or expression y is equals to ax square plus bx plus c. The process is written over there for your reference. I'm giving you the direct conclusion since it is the one shot. I would be able to write it as y plus d by 4a is equal to a times x plus b by 2a whole square. Now compare it with your standard equation. Y minus k is equal to 4a x minus h whole square. Now this a is your 4a. Perfectly fine. So depending on this a, whether positive or negative, the parabola will be downward facing or upward facing. Yes or no? Now I hope everybody is making some sense that this is k and this is h. I repeat, when we talked about parabolas, h and k came out as what? H and k came out as minus b by 2a and minus d by 4a. That's my whole point. That's my whole point, that you can use this direct formula always. Sir, what do you really mean by this? Can you explain this in a more better manner? Yes. All I'm trying to say here is a very interesting fact. Let's say if I give you y is equals to x square plus x plus 1 and one more quadratic, let's say y is equals to, let's say any quadratic, minus x square plus 2x plus, let's say 1. These are the two quadratics. So what are the methods to figure out its maxima and minima? Let's discuss two direct, standard, decent, straightforward methods. There are three actually. Conversion of this expression into a perfect square is also a method. But right now, let's cover standard two. One of the methods is differentiate it. So its derivative will be 2x plus 1. Put it equal to 0. There you get x as minus 1 by 2. So this point will be a point of minima or maxima. Now listen to me very, very, very carefully. What is the coefficient of x square? Sir, coefficient of x square is 1, which is positive. So don't hesitate in calling it will be an upward facing parabola. So if it is an upward facing parabola, just pass minus 1 by 2 to this curve, and that will be its minimum value. Which means if I pass minus 1 by 2 here, I'll have, I hope you're understanding, the minimum value of this expression will be minus 1 by 2 square is 1 by 4 plus, I hope you're understanding, minus 1 by 2 square is 1 by 4 minus 1 by 2 plus 1. It will be its minimum value, which you can find by calculating yourself. So its range will be this value till infinity. Understanding this comfortably, everyone? Sir, what about this curve? Again, the moment you see this curve, have you all not clearly noticed that, sir, in this case, the coefficient of x square is negative, so it will be a downward facing parabola. So if it is a downward facing parabola, its minima will be minus infinity, but what about its maxima? Again, the maxima is attained at the same point, minus b by 2a, comma minus d by 4a. But if you wish to use the derivative approach, what does it say? You differentiate it. So when I differentiate it, y dash, when I find, it will be minus 2x plus 2. If I put it equal to 0, minus 2x plus 2, x gives you what? 1. Yes or no? Remember that, finding the critical point method. So at x is equal to 1, you will find its maxima. So when you put x as 1, minus 1 plus 2 plus 1, I repeat, minus 1 plus 2 plus 1 will be its maximum value. Everybody understood? Yes or no? Yes or no, Virat Shukla? Everybody getting it? Any confusion so far? With this, if I could move ahead with a few more conclusions regarding polynomials, specifically quadratics, I want to give you few specific cases which we have just discussed. I repeat, sir, whenever you say that discriminant is negative of a quadratic, if discriminant is negative, which means roots are imaginary, they are not real. So in that case, the quadratic, that means parabola, will not intersect x-axis at all. And if a is positive, it will be an upward facing parabola. What if the discriminant is 0? Sir, if the discriminant is 0, roots are real but equal. Remember that case? In that case, the curve will touch the x-axis at exactly one point. Touch the curve. Sir, what if the discriminant is positive? If the discriminant is positive, which means this curve will intersect x-axis at two distinct points, because roots will be real and distinct. Everybody got it? Any confusion so far? Shall I move ahead from here? One more thing I wish to tell you is, as a fact, that if you ever find for a quadratic, if you ever find, let's say the quadratic is y is equal to ax square plus bx plus c. If a is given to be positive, and if you ever conclude that d is negative, then are you all not very clearly noticing that, sir, wherever y-axis is, the curve is always above the x-axis. The curve is always above the x-axis. And if the curve quadratic is always above the x-axis for all the values of x, it is always above the x-axis, which means it is lying clearly on the positive side of y-axis. Sir, what are you trying to demonstrate? I'm trying to tell you a very crucial and important fact, which is that this curve is attaining all the positive values only. So remember, this is a fact. IDJ uses it often. The fact is, whenever A is positive, D is negative, quadratic is always positive. For example, if I could give you one more example or case or general result in this case, let's say if I ask you x square plus x plus 1 to be solved, find the values of x so that x square plus x plus 1 is positive. One of the ways is you split the middle term and then use the wavy curve method, which we have already learned. But let's say you don't want to use it. You notice few excellent, amazing things. Sir, if I treat it as a quadratic, its discriminant is given by b square minus 4ac, which is negative. You know how to find the discriminant, yes or no? And with this discriminant, can you help me with the coefficient here? So the coefficient is 1, which is positive. So is it not that lethal combination of A being positive and D being negative for a quadratic? And whenever for a quadratic, the coefficient of x square is positive and the discriminant is negative, what do we conclude? Sir, we conclude that its graph is always going to lie above the x-axis. And if the graph clearly lies above the x-axis, it is always positive. So you really don't have to solve it. You can conclude that, sir, if you want x square plus x plus 1 to be positive, it will be positive for all the real values of x. Is it not very interesting, amazing and simple? And very, very evident, very, very simple and straightforward. Does it make sense? Have you all been able to understand this? Yes or no, all the participants? Based on that, few more conclusions can be drawn. Sir, if the coefficient of x square for this quadratic y is equal to ax square plus bx plus c is negative. So the moment we read the coefficient of x squared to be negative, we'll see downward facing parabola. So for downward facing parabola, again we see three cases. Sir, which three cases? Three cases here would mean that, sir, either the discriminant is positive. So the moment discriminant is positive, roots will be real and distinct. That means x-axis will be intersected at two distinct different unique points. If the discriminant is 0, sir, if the discriminant is 0, a being negative, parabola will be downward facing, but discriminant being 0, parabola or the quadratic will have real and equal roots. Real and equal roots. And real and equal, I hope, makes complete sense that both the roots will be same. Sir, what happens if the discriminant is negative? You tell me, for a quadratic, if discriminant is negative, it has no real roots, it has imaginary roots. It will not intersect the x-axis at all. Because roots and solutions means what? Curve where it intersects the x-axis. But here in this case, the curve does not have any real roots, so it will not intersect the x-axis, which means that here it will lie below the x-axis. So here in this case, again a very beautiful example for this y. If I notice it from minus infinity to infinity, I am clearly observing the curve is solely, completely, totally lying below the x-axis. What does that mean? Does it not mean that, sir, fx will be, the quadratic will be negative for all the real values of x? Everybody understood it. Everybody digested it. Yes or no? All the participants. Can I move ahead from here? Have you all been able to process it? Let's understand whatever we have learned with these examples. Let's consolidate it in a more better manner. Shall we? Everyone paying attention here. So first question, if I solve, what does it say? Those who are asking, sir, is it really important chapter for JEE Advanced or Mains? Sapna, I'd like to clarify, it is amazingly important for JEE Mains as well as Advanced. Not just that, in boards as well. Why? Calculus contributes 45%. Trust me, minimum 40 to 50% weightage in IDJE Mains and Advanced. What does it mean, sir? Calculus. IDJE mathematics has 5 sections, I'll say: algebra, coordinate geometry, trigonometry, calculus, and vectors in 3D. Calculus is said to be the king of maths in IDJE. And calculus has chapters: relations and functions, limits, continuity and differentiability. Then you have differentiation, application of derivatives. Then you have indefinite integration, definite integration. Then you have area under the curve, and finally differential equations. So this entire branch of calculus starts with this chapter, relations and functions. Now you tell me whether it is important or not. If you don't understand this chapter properly, you won't be able to understand the upcoming chapters properly. I hope you understand the importance of foundation. So we are laying the foundation for calculus. So if you are in 12th standard, preparing for ITJ, targeting to crack mains and advanced, this chapter is extremely important. I think I need not tell that. Yes or no? With this, let's try and answer this question. When I need to tell the domain and range of this following, I'll be solving this one and giving you this as a homework question. So if you are able to understand the logic for this, you will be able to crack this question very easily. There are 3 methods. 2 methods I have already told you. Third method I'll be using here. What is that third method? Converting this into a perfect square. I'll be solving it with that third method, which we have reserved so far. Pay attention, everyone. Let's forget this whole question. Let us deal with this simple expression which is inside the under root sign. So inside the under root sign, we have x square minus 3x plus 2. Of course, there is a square root sign, which I'll deal with later. Now with this, if I wish to simplify this, I'll try to convert it into a perfect square. Perfect square means a plus b whole square kind of an expression. A square plus 2ab plus b square. Now, if I look at this x I'll treat as a, so it looks like a square. Sir, can it be written as 2ab? I'll try to. So first of all, to have it, I'll need 2 versus this was 3. Okay, we'll adjust it. I need a, so I'll write x. But I need b. Sir, it was minus 3x. You wrote it as 2x. Where is 3? Let me bring that 3. So 2 into x into 3, and to balance this 2, I'm cancelling it by this 2. What does it mean? It means that this 2 and this 2 are getting cancelled. I'm left with 3x and that's this 3x. So everything is very well balanced. Yes or no, all the participants. Now when I move ahead, I'll say, sir, I got a square, I got minus 2ab. So I have noticed that this 3 by 2 looks like b, of course. So if this 3 by 2 looks like b, what do I do here? I'll say, I'll introduce b square as well, which means a square minus 2ab plus b square. So to bring b square into picture, I'll do this 3 by 2 squares addition here. Sir, how can you just do it like this? I mean, if there was plus 2 here, you have done something totally else. Have patience. Here, what I've done here is I have tried converting it into a perfect square by treating it as a square minus 2ab plus b square. But sir, this 3 by 2 whole square was not there at all. Okay, it was not there. Let's remove it. So for the removal of it, can I write 3 by 2 whole square getting subtracted? So is it not all still balanced? Sir, what do you mean by still balanced? I'll say that first of all, this 2 and this 2 are cancelled. So this is still minus 3x. This 9 by 4 are getting subtracted. So this is still plus 2. So nothing has changed. Nothing has changed at all. Yes or no? But sir, what have we attained by doing so? Let me reveal that. Let me reveal that part. If you are paying attention, just focus on this part. Just focus on this part. Are you noticing? I hope some of you must be noticing that, sir, this looks like a square plus b square minus 2ab. What is that? What is that? Isn't it a minus b whole square? So how do we write a minus b whole square? I'll be writing a minus b whole square as a minus b. What is b? B is 3 by 2 whole square. Yes or no? Yes or no? Plus this thing when simplified, 2 minus 9 by 4. How does it look like? 4 into 2, that's 8. 8 minus 9 is 1. Of course, minus 1. So this will give me, this here will give me minus 1 by 4. Everybody got it? Or shall I re-explain this part? Tell me honestly. What I'm trying to make you understand is if I was dealing with an expression x square minus 3x plus 2, I, with some modification, can write it as this. Everybody able to process it? Yes or no? But sir, why have we really done it? Have patience. You will understand something really amazing by the end of this question. You will love it. You will enjoy doing it. You will really appreciate doing it. Sir, this is the simplification of the expression written inside the under root sign. So if I write this fx in a more simplified manner, you are saying y is equal to under root over x minus 3 by 2 whole square minus 1 by 4. Yes, I am saying this. Now forget this whole expression. This is relations and functions. Let's talk about this. Let's talk about this separately. This part. Let's talk about this part separately. You tell me x minus 3 by 2 whole square is a perfect square. So can I not say that x minus 3 by 2 whole square being a perfect square will always be non-negative? Because when you square a number, that number is always either 0 or positive. But sir, if I subtract 1 by 4 on both the sides, I hope in inequalities you can add or subtract the same number on both sides. It does not change, which means here can I write it as x minus 3 by 2 whole square minus 1 by 4 greater than or equal to minus 1 by 4. Everybody getting it? Yes or no? All the participants. Yes or no? Sir, there is a problem. There is a problem. What is the problem? So the problem is, yes, definitely you can watch it. Why should you not? This expression is always greater than or equal to minus 1 by 4. Fine. As long as it is not inside the under root sign. But the moment I write this expression, I could conclude first of all that x square minus 3x plus 2 will always be greater than minus 1 by 4. That's your third method to find the range. First method was differentiating it, very simple, straightforward method. Second method, using those vertices of the parabola, vertex of the parabola, minus b by 2a comma minus d by 4a. Remember that method, everyone? Third method, sir, converting it into a perfect square and looking at that part. Sir, everything is looking great except for one part. Which part? that, sir, this is not merely independent expression like this. This is given inside an under root sign. So when it comes inside an under root sign, I cannot afford to keep its negative values. Are you all realizing it? Yes or no? Which means I'll preferably take its positive values only. Yes or no? I'll not take its negative values. I'll keep it positive. X square minus 3x plus 2, I'll keep it positive. Why? Because that is inside that under root sign. Sir, you could have directly said it when you already noticed that this is inside an under root sign. Why do you really have to do all what I have just done? Because that idea, that concept, that approach will help you in solving this better, or more such questions based on this concept. Although here in this question, I know since it is inside the under root sign, all I need to ensure is that x square minus 3x plus 2 has to remain non-negative, which means either 0 or greater than equal to 0. So when I ensure this, in order to find the domain, x square minus 3x plus 2, to keep it non-negative, which means either 0 or greater than equal to 0, splitting the middle term will work. So I can write it as minus 2x minus x plus 2, yes or no? And there I'll say x, when you take common, you will write it as x minus 2. What did I take common? X. To make it x minus 2, what will I take common? Minus 1 greater than equal to 0. Do you remember that wavy curve method? What does it say? Sir, one critical point is 1, other critical point is 2. You put plus, minus, plus alternatively like this. What do we want? We want it to be either positive or 0. So, sir, 0 it is at 2 and 1. Positive it is after 2 and before 1. So, values of x are going to be either less than 1 or equal to 1 or equal to 2 or greater than 2. Which means when I talk about the domain, give me a moment, students. Hold on for a while. Just give me a moment, everyone. I'm just... Just wait for a second. Okay, coming back to the discussion we all were having. I hope everybody is listening and understanding without any confusion, query or concern. So there we are. All I'm saying is that we have concluded that x could be either less than 1 or greater than equal to 2. So I know one conclusion for sure, that x could be either less than 1 or greater than 2. So everyone able to process this idea? Sir, which idea? The idea where we say that x cannot take any value between 1 and 2. If x takes any value between 1 and 2, this expression will become negative, and we cannot afford to keep anything negative inside an under root sign. Got my point? Everybody understood this basic idea, yes or no? Quickly. With this, can I move ahead? With this, if I move ahead with few more things, I hope this question I can give you as a homework question. You will try it by yourself at home as far as its domain and range is considered. Now, sir, we have still not found its range. Okay, let's talk about its range as well. So first of all, I concluded that x has to lie between these values, which means I know that, sir, here in this case, x square minus 3x plus 2 is positive or 0 for all these values. Then it will keep growing, because technically it will be a parabola like this, which will have its roots at 1 and 2. So these values between 1 and 2 I'm not taking, because they are below the x-axis, which means for these values it is negative. So what am I taking? I'm taking all the values less than 1 and greater than 2, because for these values which are less than 1 or greater than 2, this expression is positive. And it is clearly going till infinity, yes or no? It is clearly going till infinity, which means I clearly know this conclusion now pretty well in a very crystal clear manner, that, sir, this x square minus 3x plus 2, is clearly between 0 to infinity for all the values of x which are like between this. So this part over here will be called the domain. Everybody able to digest and accept the fact what is domain? All the acceptable values of x. Now look at the next part. The next part is, can we talk about its range? Sir, an expression which is always non-negative. So it's a square root. It's a square root, which means x is square minus 3x plus 2. That will also be non-negative. Because if you take square root of all the non-negative values, it is also going to be non-negative. So what about the range here? Is everyone able to predict? The range is going to be all the values from 0 to infinity. Has everyone understood it? Yes or no? Has everyone been able to process it? Yes or no? All the participants. Give me a quick confirmation. Did you all get it? Did you all understand this? With this, I think quadratics you have been able to understand pretty well. Shall I now talk about trigonometric functions? Shall we discuss trigonometric expressions? Yes or no? Everyone, please pay attention now. When we talk about trigonometric functions, sine, cos, tan, cos x, sec, cot, these are 6 trigonometric functions. If I begin with sine, I hope you do remember that in a sine, trigonometric ratios, identities, functions, equations you must have studied in 11th as well. So for trigonometric functions, sine, we discussed that it begins with 0 and it is a sinusoidal wave which just keeps on going like this. So it is clearly a periodic function. So here we are saying that it is a periodic function. And I hope few general facts regarding sine you know, which are that it lies between -1 and 1. So it never goes above 1, it never goes below -1. It stays compacted between -1 and 1. Yes or no, everybody? Along with this, there is one more very interesting fact. Sir, sin x is an odd function. What do you mean by odd function? Whatever curvature you see on the right of 0 in the first quadrant, the same reflection, same symmetry you see on the left of 0 in the third quadrant. So if you ever see a function for which f of minus x is found to be minus of f of x, we call it odd function. So in that case, I hope you are realizing sin x is clearly demonstrating that property that sine of minus x is minus sin x. So we'll call it to be an odd function. One more very crucial thing I want to notice and highlight here, which is that if you notice this part, which part, sir? Its curvature. Which curvature? This part. 0 to 2 pi if you take it. If you take it from 0 to 2 pi. This curvature. 0 to 2 pi if you take it. The same curvature keeps on getting repeated. I repeat, the graph which we are noticing from 0 to 2 pi, the same graph exists from 2 pi to 4 pi, then 4 pi to 6 pi, then 6 pi to 8 pi, and so on. What does it imply? Sir, it implies that it is a periodic function. It is clearly a periodic function where its period is given by 2 pi. What do you mean by period? That same zone which is getting repeated, that same tendency which is getting repeated. I hope all the conclusions which I have given regarding sin x, odd, periodic and all is understood by everyone. What about 1, 1 or many 1? What is it? 1, 1 or many 1? Horizontal line test if you try. I hope everybody must be noticing that, sir, if you draw a line parallel to the x-axis, are you not noticing that this line is intersecting this curve at more than 1 points? So if the line happens to intersect the curve at more than 1 points, this is clearly many 1. Yes or no? So this is odd as well as many 1. I hope no confusion regarding this. 1, 1 is called injective. So many 1 is not injective. I hope there is no confusion. So regarding this domain, when we say, sir, on the x-axis, it exists from minus infinity to plus infinity. So domain is all real numbers. What about its range? Sir, its range is going to be -1 to 1 because it stays confined between -1 and 1. Yes or no, all the participants? Got my point, everyone? Shall I move ahead from here? Any confusion regarding this? Similarly, can we now talk about cos x? You just shift the graph of sin x. You just shift the graph of sin x by pi by 2 units on the x-axis, along the x-axis on the left side. You will notice the same curve becomes the graph of cos x. What is happening over here is that you please pay attention. Sin x was going like this. Sin x was going like this. I mean, it passes through 0 and pi, of course. So sin x was going like this. You just pulled it by pi by 2 distance along with the x-axis on the left hand side, by which I got the graph of cos x. It's simply an observation. What I'm trying to tell you here is that again, when you notice, sir, the graph exists on the x-axis from negative infinity to plus infinity, which means its domain is going to be all the real numbers, yes or no? Like sin x, cos x also stays clearly between -1 and 1, which means along with the y-axis, the graph is there between -1 and 1 only. So its range is going to be -1 and 1. Able to comprehend this as a fact? Now you tell me again, 1, 1 or many 1. Sir, it is periodic. It is bounded to be many 1. Because again, if you do that horizontal line test, where you draw a line parallel to the x-axis, it is clearly intersecting this curve at more than 1 points. What does it mean? It means that it is many 1. Everyone processing it. Now, sir, odd or even? You tell me odd or even. What kind of function it is? Odd or even, students? Sir, for odd, it is symmetrical with respect to origin in the opposite quadrants. So to be even, it has to be symmetric with respect to the y-axis. So is it symmetrical with respect to y-axis? Indeed it is. Yes or no? I hope everybody is clearly noticing that, sir, the curve which we are seeing on the right of y-axis, the same curve which we are seeing on the left of y-axis, which means it is an even function. So how do we define even? I hope you do remember. For even, I'll say f of minus x is equals to f of x. If a function follows this definition, it will be called an even function. So cos x is clearly following that definition, that cos of minus x is cos x. By symmetry also I can claim that. Yes or no? With this, I'll say this is clearly an even function, many 1. I hope no confusion. Is it periodic? Is it periodic? I hope everybody has realized again that, sir, whatever portion which was there at 0, and if I continue it till 2 pi, this portion if I look at, 0 till 2 pi, the same portion keeps on getting repeated. The same portion getting repeated. So do many 1 functions called bijective. Sapna, if a function is 1, 1 and onto, if a function is both 1, 1 and onto, it is called bijective. And we can find inverse of bijective functions only. We'll talk about that in the upcoming part. So I repeat, this curvature is repeating its tendency from 0 to 2 pi. So this is again what kind of function, students? This is again a periodic function. And here for this periodic function, the period t is again given by 2 pi. That same domain gets repeated. 0 to 2 pi, 2 pi to 4 pi, and so on. Yes or no? Everybody understood that? Sir, what about tan? How do you define tan x? For tan x, there is only one problem. Sir, what problem? Technically, what you must have studied in possibly 10 standard as that tan theta is sine theta upon cos theta. Yes or no? Sir, sine theta being numerator could be anything, but cos theta is there in the denominator and I cannot keep this denominator to be 0, which means all those points where cos x is becoming 0 should be excluded in tan, because cos x becomes 0, tan x goes not defined. Yes or no? So cos x becomes 0 at all the odd multiples of pi by 2. Cos x becomes 0 at all the odd multiples of pi by 2. Are you noticing it? The graph of cos x intersecting the x-axis at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, and so on. So what do we conclude? Sir, we conclude that cos x becomes 0 at all the odd multiples of pi by 2. Which means what? Which means tan x will become not defined at all the odd multiples of pi by 2. And if tan x becomes not defined at all the odd multiples of pi by 2, I'll not include it in domain. Got my point, or are you still processing it? What did I just say? I said that yes, the graph of tan x when you plot or draw, you will see on the x-axis existing between minus infinity to infinity for all the values except for one simple change. Sir, the points where cos x becomes 0, tan x will be not defined. So those points should be excluded. So where does cos x become 0? Cos x becomes 0 at all the odd multiples of pi by 2. Which means if, where should I do it? Here. odd multiples of pi by 2 are given by 2n plus 1 times pi by 2, where n is an integer. I hope this part here, when I wish to ask you a question, that if cos x is 0, what is your generalization about x? Will you not say, sir, odd multiples of pi by 2? So odd is given by either 2n minus 1 or 2n plus 1, whatever you wish to, you can. So any 2n plus 1 times pi by 2, where n is a natural number, sorry, n is a integer, that should be excluded. I repeat, definitely, you need to watch two videos in that case, part 1 and part 2. This is luckily part 2. I repeat, any odd multiple of pi by 2 will be the point where cos will become 0. But if cos becomes 0, 10 goes not defined. So 10 will say its domain is all the real numbers except for odd multiples of pi by 2. But sir, when I notice the graph of 10x from minus infinity to infinity, what we observe is that it exists from minus infinity to infinity for all the points, yes or no? What does it imply? What does it imply? That implies the range will be all the real numbers. One more question I have. Can you tell me odd or even? Can you tell me odd or even? Are you all clearly not noticing this is an odd function? Sir, why? I hope everybody is clearly making some sense out of it, that here, the curve which you are noticing on the right side of origin in the first quadrant, the same symmetrical curve I am noticing on the left side of origin in the third quadrant. So if it is symmetrical with respect to origin in first and third quadrant, it is going to be an odd function. Sir, what about 1, 1 or many 1? You just draw a line parallel to the x-axis. If it intersects the curve at more than 1 points, it is clearly many 1. Yes or no? So I'll definitely say it is again many 1. And of course, it is bound to be many 1 because it is periodic. Sir, periodic? Yes. Why periodic? I hope some of you must have noticed that, sir, this chunk which we are seeing, the same chunk keeps on getting repeated. After what range? Sir, this is minus pi by 2 to pi by 2. So this is a length pi unit. So for this pi unit, whatever is the distance, the same pi unit gets reflected time and again, periodically. So this is again a periodic function. This is again a periodic function which has period as pi. Any confusion so far? Whatever we have done or discussed so far? Yes or no, all the participants? Now, if I talk about cortex, now can you not generalize here? That, sir, it will be, first of all, cortex, when I say, I'll ask you to look at it from the perspective of inverse of 10x. Sir, what do you mean by inverse of 10x? Forget it. 10x is sin x upon cos x. So cortex will be cos x upon sin x. So when I look at the domain of cot, when I look at or ask you to notice the domain of cot, what do you come up with? Will you all not say that, sir, for cot, if it is supposed to be defined, sin x has to be non-zero? Because if sin x becomes 0, the whole problem lies that denominator will become 0, expression will be not defined. So if I go back to the definition of sin x, what did I notice? So sin x was becoming 0 at all the multiples of pi. Look at the graph of sin x. Where does it intersect the x-axis? So sin x was intersecting x-axis at 0, pi, 2 pi, 3 pi, minus pi, and so on. So if I were to ask you a question that if sin x is 0, what will you say about x? Will you not say, sir, any multiple of pi? Any multiple of pi? So by that theory or logic, if I want cortex to be defined, will I not say that, sir, it can take any real number except for those points where sin x is 0? Because cot x is technically cos x upon sin x. So sin x cannot be kept as 0 because it is there in the denominator. So what will I say? X can take any real number except for certain values. With certain values? Sir, it cannot be taking n pi, multiples of pi. Because at multiples of pi, it will become 0. What will become 0? Sin x. And if sin x becomes 0, cot x will be not defined. Got my point? So any multiple of pi should be straight away avoided. Did you all get this when I talk about the domain of cortex? Everyone able to process it? Yes or no? Everyone able to process it? Yes or no? With this, one more clarity I want, expect and hope from your end. Then again, 10x was between minus pi by 2 to pi by 2 was going like this. Yes or no? So cortex being its reciprocal will just behave opposite. So first of all, it will not be defined at multiples of pi. Remember that whole idea, because at multiples of pi, sine becomes 0. Cos upon sine will be not defined. So I'll have these pi by 2, pi, 3 pi by, sorry, I'm really sorry. I repeat, x is equal to pi, x is equal to 2 pi, x is equal to 3 pi, x is equal to minus pi. All of these lines parallel to the y-axis will be behaving as in asymptotes. Because this curve will keep going towards this line, but it will never meet it. Asymptotes, I hope you understand very well. With this, can I not conclude a very beautiful, a very interesting, and a very amazing fact? What has happened to the board? That here, I'll not see it getting defined at 0, pi, 2 pi, 3 pi, and all. And the most important thing, if 10x was showing an increasing nature, cortex being its reciprocal will show a decreasing nature. Understanding my language? So with this, what will I conclude here? That sir, cortex domain will be r minus n pi. N pi, I hope, makes complete sense. But still, if 10x was defined from minus infinity to infinity, cortex will also be defined from minus infinity to infinity, which means its range will be minus infinity to infinity, which means its range will be all the real numbers. Everybody got it? Everybody understood it? Yes or no? Along with this, one more fact I want to highlight. This time, what kind of function it is? Even or odd? What kind of function it is? Even or odd? You tell me very quickly in the comments, even or odd, what kind of function it is? Again, sir, the curvature which you are seeing on the right hand side of the zero in the first quadrant, the same curvature, reflection or symmetry we are seeing on the left hand side of zero in the third quadrant. So what kind of function it is? Can you help me with the type of function here? Will you all not say that, sir, again, it is clearly an odd function? Everybody understood that. Everybody realized it. Everybody got my point. Not just that, one more very crucial fact you all must have understood. Sir, if I do the horizontal line test, which means 1, 1 or many 1. So I hope this is clearly intersecting the curve at more than 1 points. So it is clearly many 1. And of course, since it is periodic, it is bound to be many 1. Along with this, you help me with one more thing, that here, the curvature which we are seeing between 0 to pi, the same curvature is getting repeated from pi to 2 pi, then 2 pi to 3 pi, then 3 pi to 4 pi, and so on, which means what? This is clearly, again, periodic as all the trigonometric functions, and there again, its period will be given by pi. So remember this, for sine and cos, the period was 2 pi, but for tan and cot, the period will be pi. For second cosec, the period again will be 2 pi. Everybody got it? Everybody understood it? Any confusion? Any confusion? Yes or no? With this, sec and cosec are simply reciprocal of cos and sine. How I personally remember that? Let me share that technique or short trick with you. Listen to me very carefully. Notice what I'm doing here with utmost precision. I'll be sharing a very interesting, a very amazing short trick or basic pattern which I have developed with the time. What is that pattern? The pattern is that if you draw the graph of cos x, so the graph of cos x is clearly going like this. The graph of cos x between 0 to pi by 2 goes like this, then pi by 2, 3 pi by 2 goes like this, then 3 pi by 2, 5 pi by 2 goes like this. So sir, what are we drawing? We are drawing the graph of sec x. So please pay attention. All I'm saying to you is that whatever was the graph of cos between minus pi by 2 to pi by 2, just invert it. Just turn it upside down. Sir, why? Because please pay attention, if cos x ranges between minus 1 and 1, will you all not say that sec will be either between 1 to infinity or minus infinity to minus 1? Sir, why? Because I hope it makes complete sense when you go back to that reciprocal function which you all must have studied, This is how you see the reciprocal function. For reciprocal function, I repeat, if I ask you a point, this point will be minus 1 comma minus 1 and this point will be 1 comma 1. So if there is a point which lies between minus 1 and 1, if there is a point which lies between minus 1 and 1, of course 0 is excluded. So for that point, its reciprocal is either minus infinity to minus 1 or its reciprocal is 1 to infinity. Able to understand my point? Able to comprehend what I'm saying? I am saying a very simple, straight, direct fact which says that if cos x or sin x are between minus 1 to 1, their reciprocals sec x and cosec x respectively will be either greater than 1 or less than minus 1. And the technique here is pretty simple, that if cos x graph is going like this, you just turn those buckets upside down. But sir, there is one more problem. What problem? That sir, at whatever point cos x becomes zeros, at those points sec x will be not defined, yes or no? Sir, why? Because sec x is 1 upon cos x. Sec x is technically what? Sec x is technically 1 upon cos x. So if cos x becomes 0, sec x will be not defined. Yes or no? Everyone getting my point here? So the logic remains simple, that in order to keep sec x defined, I'll avoid taking the points where cos x becomes 0. And as we have just discussed when we were talking about 10x, I hope you remember, was not defined at all those points where cos x is not defined. The same logic I could develop for sec as well. For sec also, cos is there in the denominator. So at all those values of x where cos is becoming 0, sec will be not defined. And we know that point, don't we? The point is all the odd multiples of pi by 2. So what will I conclude? That again, you can take all the real values except for odd multiples of pi by 2, which is written as 2n plus 1 or minus 1 times pi by 2, where n is an integer. Do you all remember that, yes or no? Yes or no? With this, I repeat, I hope you are seeing the graph doesn't exist at minus pi by 2, pi by 2, 3 pi by 2, 5 by 2, because these lines parallel to the y-axis passing through these points on the x-axis are asymptotes, are clearly behaving as asymptotes. Able to digest it, able to process it, able to get it. Similarly, can you not help me with the graph of cosec? I hope you all must have developed the logic by now. Sir, what is the logic? Can you help me with the logic, students? I hope for sine, if I draw the graph, this is how you notice the graph of sine x. Yes or no? This is how we notice the graph of sine x. So if I again turn these buckets upside down, if I invert them, it will give me the graph of cosec. Because again, the logic follows the same. Sine x stays between minus 1 and 1. So cosec will be either less than minus 1 or greater than 1. That reciprocal function, if you are understanding. With this one more fact, I hope everyone is able to process that, sir. Technically, cosec, if you wish to define, cosec x is 1 by sine x, yes or no? So sine x I'll not keep as 0, because in order to keep cosec x defined, sine x, the denominator cannot be 0. So when does sine x become 0? So sine x becomes 0 at 0, pi, 2 pi, 3 pi, all the multiples of pi. So in the domain of cosec, I'll keep all the real numbers except for any multiple of pi. Yes or no? Everybody got it? Everybody understood it comfortably? Yes or no? Everybody? I hope no confusion regarding this. And again, when you talk about the range, sine and cos stay specifically between minus 1 and 1. But second cosec will stay between either minus infinity to minus 1 or between 1 to infinity, because they are clearly the reciprocal functions. Any confusion? Trigonometric functions, everyone comfortable with? Any confusions, queries or concerns if you have, please ask. I think this very important, very crucial, very amazing, very astonishing formula you all must have understood and learnt in 11th standard only. For example, if I'm dealing with 3 cos theta plus 4 sine theta, and if I wish to ask you its maximum and minimum value, what do you give its maximum and minimum value? Its minimum value directly is given by under root over a square plus b square. So that will be 3 square plus 4 square. But its negative will be its minimum value. And its maximum value under root over 3 square plus 4 square. This is a very crucial fact which you should remember. If this theta and this theta are same, which means if this is not alpha and this is not beta, if that something like that is given, you cannot do this. But if this angle and this angle are same, in that case, I'll always say that a sine theta plus b cos theta will fall under negative of under root over a square plus b square to positive of under root over a square plus b square, which means 3 cos theta plus 4 sine theta will lie between minus 5 and 5. There have been direct questions asked on this particular result, and the JEE community has been using this kind of results often in their questions. So I hope you would not forget this result. A very crucial, a very important, and a very amazing, insightful result, which you will see getting used at a lot of places. Will you, everyone? Shall I move ahead? Let's try and solve a question based on range, shall we? Everyone, are you all there? So let's solve this question. I hope you all must have seen the question. Will you all try it with me? So what are we asked? We are asked the range. We are asked the range. So when we talk about the range, sir, if you could say something about 2 cos x minus 1, we'll be in a very, very good position to predict a lot of results based on this. Yes or no? Hold on for a while, students. Let me just see. Just give me a moment. Let me just refresh my screen so that I can read all the comments and everything. There we are. Okay, going great. Fine. I repeat, when I wish to talk about the range, can you help me with 2 cos x minus 1? Okay, sir. The idea is that what is cos x? Sir, cos x for all the values stays between minus 1 and 1. Yes or no? Cos x for all possible values stays between minus 1 and 1. That we know. I hope nobody is confused with this as a fact. Then if I multiply it by 2 on both these sides, can you help me with 2 cos x? Sir, 2 cos x as a value will lie between minus 2 and 2. Because if you multiply it by a positive number, the sign of the inequality stays same. If I subtract 1 on all the three sides, minus 2 minus 1 is minus 3. This is 2 cos x minus 1. And this is 2 minus 1, which is 1. Everybody got my point without any confusion or hesitation. Now go back to that concept of reciprocal function if you still get confused in taking the reciprocal. This is how that reciprocal function behaves. Now for a while, imagine that this 2 cos x minus 1 is x. So this is the x-axis, this is the y-axis, and this is the graph of y is equals to 1 by x. So based on x, I'm trying to predict 1 by x. Based on the values of x, I'm trying to predict 1 by x. What is x? I'm treating x for a while as 2 cos x minus 1. That's my input. My input is from minus 3 to 1. Sir, our input is from minus 3 to 1. Of course, when you look at its reciprocal function, you clearly realize that this x cannot be 0. Our input cannot be 0 because we are going to take its reciprocal. So if we are going to take its reciprocal, x cannot be afford to kept as 0. Yes or no, all the participants? With this, if I try and tell you something really amazing, exciting, and very great, very, very fruitful and important result, will you all not say that, sir, if you are keeping x between minus 3 to 1, excluding 0, pay attention everyone, at minus 3, what do we notice? Sir, at minus 3, the value of 1 by x is minus 1 by 3. And at 1, what is the value? Sir, at 1, the value is 1 because 1 by 1 is 1. Reciprocal function it is. Now you tell me something really interesting, direct and straightforward, that what do you conclude or come up with here in this case? When I take values from minus 3 to 0, I hope the output getting generated is from minus infinity to minus 1 by 3. Processing it, everyone. When I take values from 0 to 1, the outputs which are getting produced are from 1 to infinity. Although it's very straightforward, direct and genuine, which you all could have concluded from here only. But if you ever get confused, you have your reciprocal function in picture. I repeat, what did I just say? You all must have very clearly noticed that, sir, if 2 cos x minus 1 lies between minus 3 and 1, where I cannot afford to keep it 0 because it's reciprocal I'm taking, there, if I define its reciprocal, which means 1 by 2 cos x minus 1, then it will lie between all the values from minus infinity to minus 1 by 3. Yes or no? All the values from minus infinity to minus 1 by 3. Or, one more thing you need to tell me. Can I take minus 1 by 3, students? Yes, we can. Why can I not? Because minus 3 was taken. So minus 1 by 3 will also be included. Yes or no? Or what else can I take? Sir, your outputs will lie between 1 to infinity. So between 1 to infinity means what? 1 should be included because 1 is included. So 1 by 1 will also be included till infinity. And this here is nothing but what? The range. Everybody able to process it? Everyone able to understood this? Yes or no? I hope there is no confusion on this question. Shall I try one more question? A very amazing, a very good question asked by JEE Mains as well few years back. Even this question has appeared in JEE Advanced as well. How do we solve this? Now, of course, nobody should say that, sir, here in this case, you should start solving it the way we solve trigonometric equations. Please don't try that. What is the question? If you read the language of the question, you all will be able to conclude, sir, they are not interested in the solutions. Moreover, they are interested in number of solutions. They are interested in number of solutions. For number of solutions, I'll say that try and draw its graph. Try and draw its graph as accurately as possible. Try and draw its graph as accurately as possible. What did I say just? I say that if I try to plot the graph of sin x, if I try to draw the graph of sin x, so this is how you will notice the graph of sin x being drawn. Yes or no? So this will be pi, 2 pi, and this is how it will go till 3 pi. I hope everyone is comfortably getting it. So this is how you will see it till 3 pi. And similarly, this is where you will see it as minus 3 pi. Although we don't find the number of solutions of sin x is equal to x by 10, it should give me certain points. Okay, no worries. Here, this is how we have drawn the graph of y is equals to sin x. Everybody able to process it? Yes or no? Now pay attention everyone, If I talk about this line x by 10, so I'm treating it as two functions where one function I'm taking as sin x, the other function I'm taking as x by 10. Now what I'm doing here is I'll draw both of the curves and then I'll find the points where both of the curves are intersecting. I'll find the points where both of the curves are intersecting. Give me a moment, everyone. Just hold on for a while. Just give me a second, everyone. Okay, so there we are. Give me a second. Here we are. I repeat, we have two things. One function as y is equals to sin x. Second function as gx is equals to x by 10. Understood this, everyone? Yes or no? There is a small interruption in our class. Let me just get rid of that interruption and then we'll continue. Okay, great. So what did I just say? One curve is y is equals to sin x that I've drawn. The other curve is x by 10. So x by 10, if I notice, I know from my intuition, is clearly a straight line. It's clearly a straight line. Yes or no? So a straight line, the best practice is you can draw. I hope y is equals to mx plus c. There is no c, so it will be a straight line passing through origin 0, 0. One more fact you all must have noticed very clearly here is this fact that here, that if x is 10, y will be 1. If x is minus 10, y will be minus 1. What did I just say? I am saying that here, this is 0, this is pi, this is 2 pi, this is 3 pi. So pi is approximately 3.14. So 3.14 into 2 is 6.28. 3.14 into 3 is 9 point something. So right ahead of this, there will be 10 somewhere here. And right before 3 pi, this is minus pi, this is minus 2 pi, this is minus 3 pi. So right before minus 3 pi, just before minus 3 pi, there will be minus 10. Now, two outputs I am getting here are these very standard and direct one are that if x is kept as 10, 10 by 10 is 1. So there will be a point 10 comma 1 like this. And if x is tried as minus 10 by 10 will be minus 1. So there will be a point minus 10 comma minus 1. Everybody got it? Everybody understanding my point? Now, if I join these 2 points, ensuring that this line also passes through origin as well. So if I join these 3 points, which 3 points, students? This point here passes through origin and keeps going till this point. Everyone understood that? Everyone understood this whole thing here, or shall I repeat it? What did I do? I started drawing this line, ensured that it passes through origin and it is taken till 10 comma 1. What did I just do? I knew that this point over here, was 10 comma 1. I knew that this point over here is minus 10 comma minus 1. And we all know that this point over here is origin 0 comma 0. So we know one thing for sure, which is that this curve sin x and this curve x by 10 are intersecting at certain points. Sir, why are you drawing this curve till this stage only? Because after this sin x will keep going on, but this curve or this line will go above the curve sin x. Before minus 10, on the left of minus 10, sin x will keep going on between minus 1 and 1, and this curve, this straight line, will go below minus 1. So there will be no further intersections between these two curves before minus 10 and after plus 10. Getting my point, everyone? Yes or no? With this, if I ask you the points where they are intersecting, can you not help me? That, sir, the points where these two curves are intersecting is 1, 2, 3, 4, 5, 6, 7. After this, there will be no intersection. Before this, there will be no intersection. So number of intersections, if I could notice, the points where they intersected, I could notice are clearly these which are shown to you with these red marks. Excellent, excellent. So with this, I am sure it makes complete sense and it stays understandable that here, these two curves are equal means what? These two curves intersect at how many points? And with the graphical understanding of ours, we could develop or deduce that these two curves are intersecting at how many points? 7, I think. 2, 4, 6, and 1. So number of solutions will be 7. Has everyone understood that? Has everyone gotten it? Are you all being able to process it? Are you all able to process it? Was it not straight, direct, decent, simple? Shall I move ahead from here, all the participants? Can we go ahead from here? Now let's begin our discussion with inverse trigonometric functions. Shall we? When I start my discussion on inverse trigonometric, there is a cousin of mine. She is in 9th standard. She reads trigonometric as trigonometric. So we are talking about inverse trigonometric functions, right? So let's get back to it, everyone. I repeat, when we looked at which function, students? Trigonometric functions. So when we noticed trigonometric functions, I hope you all must have seen the problem. So what problem? That if I ask you certain angles, let's say if I give you certain values of x1 and x2, then they were producing the same output because sine, cos, tan, sec, cosec, cot, they all are many one. They all are many one. They all are many one means what? if there are multiple inputs here, they were producing the same output for all the trigonometric functions. So trigonometric functions are first of all many one, and they being many one create the whole problem in defining their inverse. Because if I define their inverse means what? Whatever is the domain here and whatever is the codomain here, even if I make the codomain same as range for a while, then domain becomes codomain or range in that case, and range becomes a domain in case of inverse. But sir, the whole problem stays very simple that here, if all the trigonometric functions sin x, cos x, tan x, sec x, cosec x, and cot x all are many to one, how can you define their inverse? Are you understanding the challenge? The challenge is if they are many to one and if I wish to take their inverse, what is happening here? If I wish to take their inverse, what would start happening is for multiple y, for example, y1, I'll get multiple x. For let's say some other y2, I'll get multiple x. And if something like this gets created in terms of relations, this could be a relation, but this is not a function anymore. This is not a function anymore. Why am I calling it not a function anymore? Because here, this relation is one to many. And if a relation becomes one to many, what's the problem? Sir, the relation fine being one to many, but this cannot be called a function because function says one very straightforward direct definition which says that for all the elements in the domain, there should exist unique images in the codomain. And what's the challenge here? The challenge is pretty simple that here elements in the domain have different, not just distinct or unique, but multiple images. And if you are seeing multiple images, what do you say? Sir, we say, give me a moment, everyone. Let me just remove these elements. Coming back to the discussion. So here, this is a crystal clear violation of the definition of function. Why? Because I hope everybody is very clearly noticing that y1, despite being an element in the domain, has multiple images here. Able to process this idea. So this got violated, which means inverse function cannot be defined as far as trigonometric functions are considered. I think yes, up to an extent that's true. But if we do some modifications, sir, what do you mean by doing some modifications? Let's say I am still interested in defining the inverse of sin x. Okay. So let me go through the graph of sin x one more time. Sir, graph of sin x is huge and lengthy, but if I restrict it from minus pi by 2 to pi by 2. If I don't stretch it before minus pi by 2, if I don't stretch it after pi by 2, then what happens? If I keep it restricted between minus pi by 2 to pi by 2. So what have you attained by doing this, sir? I am saying, first of all, its range is still minus 1 to 1. No worries about that. But now sin x, I have restricted for all the values of x between minus pi by 2 to pi by 2. So if I fix this part, where I'm not taking all the real values of x, I am confining this x between minus pi by 2 to pi by 2. Although sin x is extended further, so extended further means it keeps going like this. It keeps on going like this. But I'm not continuing it further. I am pushing it to stay between minus pi by 2 and pi by 2 between x-axis, on the x-axis. Although it takes all the values from minus 1 to 1 on the y-axis. So its range is still intact, but I have played a little with its domain. I'm not taking all the real numbers. I'm keeping it specific between minus pi by 2 to pi by 2. Then sir, what is the advantage here? The advantage is pretty simple, that now you have ensured that if you're defining this function f from minus pi by 2 to pi by 2 to minus 1 to 1, then everybody please pay attention. This thing here is called the domain. This thing here is called the codomain. codomain is equal to the range. So do you remember, if range and codomain are same, the function is called onto. One more very beautiful, important and insightful fact, that here this function is clearly 1, 1. If you do the horizontal line test, for no two values of x, we are getting the same value of y. Definitely. Now with this, please pay attention. This is not just onto, it is 1, 1 as well. What is 1, 1? 1, 1 in another language is called an injective. Onto is called surjective. So if you ever see a function which is 1, 1 as well as onto, or in some other language you may call it injective as well as surjective, we call such function to be bijective. Somebody in the beginning of this session was asking what is bijective. A function which is 1, 1 as well as onto. A function which is injective as well as surjective is bijective. Now, why are we bringing the discussion of a function being bijective here? Here I am bringing this discussion because I want you all to understand that if a function is found to be bijective, then its inverse can be found. Which means if I wish to define inverse of f, so in that case, codomain or range, because it is onto, so codomain and range will be same. So its codomain or range will become the domain. So here for f inverse, -1 to 1 will be its domain. And the domain of f minus pi by 2 to pi by 2 will become its range or codomain, whatever you wish to call it in this case, because it is bijective. Okay, sir, we are able to understand it, but what have you attained by doing this? I hope everybody is clearly realizing one very crucial and important observation, that sir, now, if you wish to plot the graph, if previously while drawing the graph of y is equals to sine x, x was technically an angle and y was technically a value, yes or no? So I was giving x as an input, the angles y was getting produced as a value. So I restricted it between minus pi by 2 to pi by 2 so that I could get values between -1 and 1. But here I am defining its inverse now. So its inverse means what? I am defining the curve as y is equals to sine inverse x. Now, mind you students, this y will be the output, which will be the angle now, and this x here will be the input, which will be the value now. Able to digest my statement? Let me make you understand this. I repeat, this x now in terms of inverse of sine will be the values between -1 to 1. So here I'll get these values between -1 to 1 here. Definitely, after this session, this entire PDF will get uploaded on our WhatsApp channel. The link to our channel is given in the description. And all these outputs minus pi by 2 to pi by 2 will become our outputs. So they'll be plotted on the y-axis. Are you able to process all what I'm saying? So now the graph of sine x, if you draw, the graph of sine inverse x which you draw will look like this. Everyone able to process it? Yes or no? Everyone able to process it? This clearly is nothing but the graph of y is equals to sine inverse x. I repeat, here on the x-axis, it's not the angle anymore, it's the values. On the y-axis, we are having the angles. Everyone getting it or not? Yes, Sasi Meena, I got your query. We will take a session on 11 standard maths as well. Don't worry, we'll do it. We'll get it planned and we'll execute it. Did you first of all understand that sine x, despite being a function many to 1, its inverse could not be defined because it will become 1 to many in that case? So there, what did I do? I simply restricted it between minus pi by 2 to pi by 2 so that I could ensure that it becomes bijective and then its inverse can be found. So if it became 1, 1 and onto, I could define its inverse, and there I defined its inverse with this approach. The thing which I do with sine, the same thing I'll do with cos, but with cos, I'll restrict it between 0 to pi. So this is 0, this is pi by 2, and this here is pi. So I repeat, if you have f, a function which is cos x technically, defined from 0 to pi which has its codomain from -1 to 1. Everybody able to notice -1 to 1, yes or no? In that case, what is happening over here is, pay attention everyone. In that case, if it stays between -1 to 1, I'm restricting x to be between 0 to pi. This function again becomes 1, 1 and on 2. The graph clearly tells you that there are no two values of x for which the same y getting generated, which means it is clearly 1, 1. What is onto here in this case? Onto means the codomain and range are same. Range of cos x for 0 to pi is -1 to 1. Codomain is also this. So this function is clearly 1, 1 and onto. First thing. If this function is 1, 1 and onto, which means it is injective as well as surjective. If it is injective as well as surjective, it is bijective. So if this function is bijective, I can define its inverse. If I wish to define its inverse, which means this function which I took as cos x, I wish to define its inverse now. So to follow its inverse, I'll say that this f inverse will have -1 to 1 as its domain and 0 to pi as its codomain or range in this case, because it is bijective. Yes, 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 definitely. Why would it not be there? So with this, if I now wish to plot it, sir, 0 to pi, which was the input, will become the output now. Yes or no? So this point will be 0, this point will be pi. -1 to 1, which was the output, will become the input now, because it is the inverse now. So this will be -1 for a while. Let's say this is +1 for a while. Can I say so? Now I hope you are clearly realizing cos inverse x if I wish to draw, cos inverse x if I wish to draw, I hope it makes complete sense if I draw its graph like this. Because cos pi is -1, so cos inverse -1 will be pi. Cos pi by 2 is 0. I hope you remember that. So cos inverse 0 will be pi by 2. And cos 0 is 1, so cos inverse 1 will be 0. Everyone able to process how did I draw the graph? Although you can always remember this as a fact that ever, if you get a curve fx and f inverse x, then these two curves are always symmetrical with respect to the line y is equals to x. What did I just say? Let's say if I'm giving you a curve y is equals to e to the power x, another curve, let me call it fx as e to the power x, then you can always say that f inverse x will be log x at base e, because e to the power x and log x at base e are inverse of each other. Yes or no? Remember that? So there you reach to a conclusion that if I draw the graph of e to the power x and log x, I hope you do remember, this is how the graph of log x looks like, and this is how the graph of e to the power x looks like. And there, if you draw a line, which line? Y is equals to x, so this is that line, y is equals to x. So always remember, the straight line y is equals to x behaves as a mirror for two curves which are inverse of each other. What did I just say? That whenever you wish to define the inverse of sine, just take its mirror image with respect to the line y is equals to x, you will be able to draw the graph of sine inverse x. Not just that, here. If I wish to define the graph of cos inverse x, I take the mirror image of cos x with again the line with respect to the line y is equals to x, and my job will be done. Everybody got it? Everybody understood it? Or shall I repeat it? Yes or no? In that same fashion, in that same manner, can you not define the graph of tan inverse x now? But sir, kindly help us in restricting tan x first, because tan x is again what? Tan x is again many to 1. And if it is again many to 1, the problem is again the same. 1 to many it will become. If I take its inverse, it will not be a function anymore. So my first primary job is to restrict it. Let's try and restrict it. So again, if I talk about tan x here, so y fx as a function I'm defining as tan x. So this is y-axis, this is x-axis. I'll be confining it between minus pi by 2 to pi by 2. So if I do so, trust me, the whole thing is done. Why? Because this is how tan x looks like between minus pi by 2 to pi by 2. So what is the advantage of it? The advantage is pretty simple. This I hope is clearly visible to everyone. It is 1, 1. So if I define this function 10x, not for all the real values, but from minus pi by 2 to pi by 2 open to all the real values. So this is its range, which I keep as its codomain. And the most important and crucial part, I restrict it between minus pi by 2 to pi by 2. In that case, what happens over here is, I have ensured that this function 10x, which is technically a periodic, I made it 1, 1 on 2. And if I could convert it into 1, 1 on 2, I think my job is done, because it is injective as well as surjective, which means it is bijective, which means it is invertible, which means I can find its inverse. So if I can define its inverse, I am saying a simple fact here, that if I wish to define the inverse here, so this range will become the domain. This domain will become the codomain or range, whatever you wish to call it. And now I'll be able to define the inverse of this, which I'll be writing as 10 inverse x. But sir, how will the graph look like? The graph will be pretty simple here in this case. Will you all not say that, sir, the input was minus pi by 2 to pi by 2, that will become the output. Inverse, I hope you are understanding now. So that will become the output. And the output, which was all the real numbers, minus infinity to infinity, will become our input. Yes or no? Everybody able to process it? So if I wish to draw the graph of 10 inverse x, its graph goes like this. This is how you will see the graph of 10 inverse x coming into picture. Everybody able to understand it, everybody able to digest it, that how are we developing inverse trigonometric functions from their trigonometric functions. So if I could develop it for these three, can I just directly give you the remaining three: sec inverse x, cosec inverse x, and cotec inverse x? All of these things we have discussed in a very detailed manner, although we'll discuss it in a more detailed manner when we discuss the chapter ITF, inverse trigonometric function. So all of these properties, I'll cover separately when I talk about the chapter ITF, inverse trigonometric functions. Right after the chapter relations and functions, the one shot which we'll bring will be based on ITF. So there I'll cover it in a more detailed manner, don't worry. So there I'll discuss all the properties of ITF, all those rules, versions, and everything. But before I do that, let's solve a question. What is that? Here I'm asked that, sir, tell us whether these functions are identical or not. Find the values. Okay, not the identical or not. Find the values of x for which the following pair of functions are identical. So I'm not solving the second one. Second one I'll give you as a homework. First one I'm solving. I hope everyone is focused. So first one, if I wish to solve, how do we do it? Sir, you want to ensure that both the functions are identical. Yes. So first of all, in the last lecture, in Relations and Functions Part 1, which got released last week, we did discuss two functions are identical if they fulfill three conditions. Which three conditions? Two functions are said to be identical if, let's say there is a function fx and gx. So whatever is the domain of fx, that same domain should be there of g of x. Second conclusion, sir, whatever is the range of fx, that same range should be of gx. Sir, is it necessary and sufficient? Absolutely not. The third condition, whatever output fx produces for a certain value of x, the same output should be produced by that same value of x by gx2. If these three conditions get fulfilled, I'll say that fx and gx are identical functions. Which means what? Which means here in this question, if I wish to check this first one, second one I'm giving you as homework, the first one, tan inverse x plus cot inverse x, and this one, sin inverse x plus cos inverse x, whether they are identical or not. Okay, let's work it out. Pay attention, everyone. It's a very interesting property. You'll learn a lot from it. Tan inverse x plus cot inverse x. If you pay attention, everyone, you just tell me one thing very clearly. Tan inverse x. Remember this x. This x is not an output, it is an input. This x is not an output, it is an input, because tan inverse x is technically a theta, an angle. So I hope you remember, for tan inverse x, which is an angle, output stays between minus pi by 2 to pi by 2. Remember that? Tan inverse x, the graph which we have just seen here, the output stays between minus pi by 2 to pi by 2. But sir, for tan inverse, you said that the input can stay between minus infinity to plus infinity. Okay. So here I'm trying to define a very crucial and important fact, that tan inverse x is defined for all the real values of x. Similarly, cot inverse x, if you notice the graph of cot inverse x, it is also defined for all the values between minus infinity to infinity, which means cot inverse x also has a domain x. Getting my point, everyone? So tan inverse x and cot inverse x both are defined for all the real values of x. Getting it, everyone? Yes or no? With this, I am sure you're able to conclude that the domain of tan inverse x plus cot inverse x will be the domain of this intersection, this. So intersection of real number with all the real numbers is real number. So tan inverse x plus cot inverse x is defined for all the real numbers, which means I could assess the domain of fx as all the real numbers. That's the domain of f of x. Everybody able to get it? Now, let me define g of x. Can you help me with sine inverse x? Do you remember that's in a sine inverse x? I hope even if I show you this graph here, for sine inverse x, the inputs which you were taking here are clearly from -1 to 1. Remember that, everyone? Same I tell you for cos inverse, the inputs which we are taking are from -1 to 1. I repeat, whether you take sine inverse or cos inverse, both will say that this x has to lie between -1 and 1. Not just sine inverse, but cos inverse as well will say that keep x between -1 and 1. Which means what? Which means the domain of gx. What is gx? Sir, gx is summation of sine inverse x with cos inverse x. Yes or no, everyone? So gx is summation of sine inverse x and cos inverse x, which means gx will be intersection. The domain of gx will be intersection of domain of this and this. And here, are you not realizing that intersection of -1 to 1 with intersection of -1 to 1 is -1 to 1? What does it mean? It clearly means that gx will be defined for all the values of x between -1 to 1. Now, something very important, very beautiful, and very interesting I'll tell you in the next session where I'll cover ITF. I'll be proving this as a fact. That tan inverse x plus cot inverse x is pi by 2 for all x which are real. Not just that, I'll prove this also as a fact, that sine inverse x plus cos inverse x is also pi by 2 for all x which are between -1 to 1. Either of them I'm proving right now so that you get the idea. How? Let's say for a while I take sine inverse x as theta. Can I say so? So if sine inverse x is theta, sine theta will be x. Yes or no? Now, one thing you all know for sure, that sir, if sine theta is x, this sine theta I can write as cos 90 minus theta, which is cos pi by 2 minus x. Yes or no? I'm really sorry. This is theta here. So cos pi by 2 minus theta is also sine theta. Which means what? If sine theta was x, sine theta can be written as cos pi by 2 minus theta. That is also x. What does it mean? Does it not mean that cos inverse x will be pi by 2 minus theta? Yes or no? I repeat, cos inverse x will be pi by 2 minus theta. Everyone able to process it? Yes or no? With this, I want to tell you that let's pick theta from here. What is theta? So theta is sine inverse. So if theta is sine inverse x, if I push it here, I have cos inverse there is equal to pi by 2 minus sine inverse x. Getting it, everyone? Yes or no? Getting it, everyone? Yes or no? Yes or no? And sine inverse x, if I bring here, will it not result into this? The same complementary angles property you can apply on tan inverse and cot inverse, and that summation will also lead you towards pi by 2. What does it mean really here, sir? That means that tan inverse x plus cot inverse x is pi by 2. Sine inverse x plus cos inverse x is pi by 2, which means they both produce the same output. They both produce the same output. Yes or no? Just give me a second, everyone. I repeat, what did I just say? I am saying that tan inverse x plus cot inverse x is pi by 2. Sine inverse x plus cos inverse x is pi by 2. That means they are producing the same output, which concludes that their range is same. So, sir, their domains were different, but their range is same and they are producing the same output, which is for any value of x, they'll give you the same output. But the real challenge lies here with one conclusion that, sir, if I wish to make them identical, I needed to ensure that their domain remains same. So if this was saying that its domain is -1 to 1, if this was saying that its domain is all the real numbers, their domains have to stay same in order to conclude that these two functions are identical. So, sir, gx says I'll stay between -1 to 1. fx says I can take all the real numbers. So what is going to be the confined, restricted, more common version so that both come on the same page? So to bring both of them on the same page, so this can take anything, but this stays between -1 to 1. So if I ask him to stay between -1 to 1, they both will come to the same conclusion. So for the first question, I'll say, if fx and gx, if domain of fx and domain of gx is brought to between -1 to 1, if brought to this conclusion between -1 to 1, I'll be in a position to conclude that they'll become identical because their output is same pi by 2. Their range is same pi by 2. They're producing the same output for same input, fx and gx both. But the only conclusion or confusion was that, sir, fx was defined for all the real values, gx was defined for -1 to 1. So they were not identical. Understanding or not? This as my final conclusion or fact. Shall I move ahead from here? Yes or no? With this, I'll move towards exponential function and logarithmic function. But before I do, let us take a break. So it's 7:50 right now, 52 I'll say. Let's resume at 8 o'clock. Will that be fine? Let's resume at 8 o'clock or 8:05. Let me have a decent break. So let's resume at 8:05. Will that be fine? It's a break. कर दिया तुमने कनेक्ट, रिफ्रेश कर देना बस। Hello, hello, hello. Come back, everyone. If you all can hear my voice, if you all can see my voice, how can you see my voice? If you all can listen to my voice, if you all can still hear me, come back, everyone. If the system is still open, if the phone is still there open, and if you were just walking around, if you're just having some water, hydrating yourself, come back, everyone, if you all can hear me. Give me a quick response. Am I clearly visible and audible? Quick update. Shall we resume, everyone? Can you all hear me? Can you all see me? Everyone, shall we get started? So we'll be discussing exponential and logarithmic functions, although you know a lot about exponents and logarithm. But if I still could give you basics on exponents and logarithm, I'll give you this basic idea. What or how do exponents behave? Let's say 2 to the power -1. It is 1 by 2. 2 to the power 0, that's 1. 2 to the power 1, that's 2. 2 to the power 2, that's 4. 2 cube, that's 8. 2 to the power 4, that's 16. Are you seeing that if I keep this 2 fixed, this 2 I'm calling base for a while, this 2 I'm calling the base for a while, but if I keep playing with the powers, if I keep playing with the powers, which I'm calling as the input, the output which is getting produced is changing so rapidly, is changing so rapidly. First of all, I hope you're realizing X could take any real value, negative, 0, positive. Base I have fixed as 2 for a while just to make you understand this. The Y output is still definitely clearly positive, but it is changing so rapidly, the power of exponents. What does it mean? It means that here, if you are given an expression like this, where you're fixing the base as 2, let's say for a while, then if I could try and plot its graph could draw like this. I'm just drawing the graph of y is equals to 2 to the power x. So x is clearly taking any value from minus infinity to infinity. That's your input. But when you talk about y, which is 2 to the power x, so this 2 to the power x, the outputs, if you notice, are taking only the positive values. Because no matter whatever power you raise to this 2 to, it will never be 0. It will never be negative. It will always be positive. Even if you try 2 to the power minus 100, it will come out as 1 by 2 to the power 100. 2 to the power 100 is a very small number, but 1 by a very small number will still be, I hope you're realizing, something significant. But it will not be 0. It will not be negative. That's my point. My point is pretty simple here, students, that 2 if fixed as a base. If I play with the powers, I can keep getting outputs, and that's how you define an exponent function. Everybody understanding exponential function, yes or no? Yes or no? So if you are able to process exponential function, there is a catch. What's the catch? I fixed the base as 2. What if I keep the base as 1 by 2? Let's say I take 1 by 2 to the power minus 2. If I take 1 by 2 to the power minus 1, if I take 1 by 2 to the power 0, if I take 1 by 2 to the power 1, if I take 1 by 2 to the power 2, if I take 1 by 2 to the power 3, and so on. Let me show you the outputs in this case. 1 by 2 to the power minus 2 is 2 to the power 2. 2 to the power 2 is 4. So this output gives you 4. This is 2. This is 1. This is 1 by 2, which is technically 0.5. This is 1 by 4, 0.25. This is 1 by 8, 0.125. Are you not realizing in this case that base, I think that's exactly what I told Murli, didn't I? So I am saying that if base, I am keeping something less than 1. Of course, base I'll ensure to be positive, but if I keep the base between 0 to 1, and if I increase the powers, if I play with the powers, so again, I'm saying the powers are the values of x. Base I have fixed as a, which is 1 by 2 in this case. The outputs are rapidly decreasing. If I plot its graph, if I try and plot its graph will be drawn like this. This is the graph of y is equals to 1 by 2 to the power x. I really repeat the same part again. I can try any value of x from minus infinity to infinity, which means power can be any real number without any doubt or without any hesitation. But if you again look at this part where we're talking about 1 by 2 to the power x, this is still positive above the x-axis. I have recorded a video on it, a short on it. You visit our channel PWJ English. On it, we have recorded a short on it. You just look for it. You will get a crystal clear, structured, systematic video which is explaining the minimum marks required for NIT. With this, I hope you got this point, a to the power x. Yes or no? Are you processing this fact? What fact, sir? What are you talking about? I am talking about a very crucial function which I'm defining as y is equal to a to the power x, where we are confining this a between two numbers, either as 0 or 1, or I'll keep a as greater than 1. But I'll ensure a does not become negative and a does not become 1. Sir, what happens if a becomes 1? Can you tell me that if in this case, come on, if a becomes 1, 1 to the power x if there is a function. Now, sir, 1 if fixed as a constant. If you keep trying different values, 1 raised to any power will keep you getting output as 1. So in that case, is it not equivalent to a constant function? And for constant function, the graph will go like this only. Yes or no? So while defining the exponents, although there are some more constraints, but I'm simply defining you these or giving you these two things, that here, a, if I keep between 0 and 1, or a, if I keep, hold on for a while, students, a, if I keep Just give me a moment, everyone. There is something going on. Okay, coming back to this. A, if I keep between 0 and 1, or if I keep A greater than 1, in that case, what happens here is, I hope everybody is paying attention, that sir, A to the power x. There, I am defining that x can be any real number, but y will be a number which is positive. Everyone getting it? So there will be two scenarios. When the base is between 0 to 1, the exponential function goes like this. When the base is greater than 1, the exponential function goes like this. Able to process it, everyone? Yes or no? Yes or no, all the participants? Shall I tell you a very simple, a very interesting fact, which I have just told to students? I repeat, pay attention, everyone. Let's say I am drawing two graphs, just two graphs. Two graphs, if I could show you, let me show those to you on a tool online. Let me just try and help you in visualizing something very interesting. Pay attention, everyone. So if I could show you something very interesting, let's do that. A very interesting result, a very interesting fact I wish to show to you all. Pay attention, everyone. Let's say here, I am drawing two graphs. I am drawing two graphs. Sir, which two graphs? The first one being y is equal to 1.1 raised to the power x. That's one of the functions I'm taking. And the second function which I'm taking is, y is equal to, let's say 0.9 raised to the power x. I hope everybody is realizing they are the exponential functions. They are the exponent functions. Can you notice them? 1.1 to the power x, 0.9 to the power x. So if I draw these two curves, are you noticing something very beautiful? Imagine that you are here. This is day 0 of your IDJE preparation. You start your preparation on this day 0. Now the days pass, and as the days pass, look at with this slight difference in your preparation. If it is constant, it is constant. But if you just keep improving by 0.1, or if you keep worsening by 0.1, if you keep deteriorating by 0.1, or if you just keep improving by 0.1, look at the change. Look at the change. Look at the change. Look at the beautiful, amazing, exciting, exponential change. Where will you reach if you just keep developing y? 0.1 every day. And where will you reach if you just keep worsening yourself, if you keep deteriorating yourself by 0.1 every day? That's the power of exponents. Are you noticing that? How rapidly you improve with small changes in your routine. Solving few more questions, revising your notes, practicing or attempting mocks. And if you just keep skipping those regular practices every day, how brutally you ruin your performance. Are you realizing that? That's the real world application of your exponential function. And that's exactly what I'm trying to highlight here with this. Got my point? Understood my point? With this, I'll now talk about the logarithmic function as well. First of all, I hope since you are in 12th standard, you know what is logarithm, you know how to process it, how does it get derived. Tasmim, I have already told you that we have recorded a short on it. If you search for it on our PWJ English channel, that minimum marks required for NIT, I have covered it in a very detailed, descriptive and a comprehensive and thorough manner. You just go and watch it. You'll get complete crystal clear clarity on this. Will you? Got my point? I'm repeating it twice. With this, if I now tell you that, sir, if 10 cube is 1000, so this is how you write in terms of exponents, because larger numbers, when we were dealing with astronomy and all, we needed bigger numbers and calculation was very much time consuming. So Napier and all developed logarithm, technically Napier. And he came up as a conclusion that with larger numbers, how can you deal with multiplication and all, so that your calculation becomes simpler. So there Napier invented or discovered logarithm. So he said that if 10 cube is 1000, in the language of logarithm, log of 1000 at base 3 is 10. Are you able to relate exponents with logarithm and logarithm with exponents? What did I just say? I said this 3 raised to the power 10 results into this 1000. Oh, I think I made a mistake. I'm really sorry. I am really sorry. I'm really sorry. Log of 1000, I'm really sorry for this mistake. Add this base 10 will be 3. So, logarithm and exponents, if I relate, pay attention everyone, this 10 raised to the power 3 will result into 1000. That's what or how you relate logarithms with exponents. So if I could give you a very simple conclusion here, let's say if we were developing an exponent functions as y is equals to a to the power x, then in terms of logarithm, how will I write? I'll say log of y at base a will result into x. Are you again not realizing that they are inverse of each other? The exponent function and logarithmic function are clearly inverse of each other. So why are you saying this? Because if x was behaving as an input here, y was getting produced as an output there. The same thing is happening over here. The y, which is now passed as an input here, producing x as an output here. And that's exactly how inverse functions behave. Yes or no, everybody? Now, what's my question here is that here, for exponential function, what was about input? So here, this x which was input could take all the real numbers, but y as an output could generate all the positive values only. And regarding a, we know this very clearly that a has to be positive but not 1. Remember that. The same extension, if I introduce here or stretch here or continue here for this inverse function of exponent which gets introduced as logarithm, will I not say that here in this case x is output, that same which was input there? So this output could be any real value. This is that same x which was there as an input. And here, this y which is treated as input for log, which was output for exponent, is going to take values from 0 to infinity. Sir, what about a? I think for both of the cases, this a, we have just concluded that a has to stay positive and a cannot be 1. Are you able to relate logarithm with exponents? And as I have clearly mentioned and just told you, that if you ever wish to draw a function in its inverse, the beauty lies in the line y is equals to x. What did I just say? If we saw the graph of, I hope you remember, a to the power x somewhat like this. This is how we draw the graph of y is equals to a to the power x, where I told you a was greater than 1. Then just the mirror image of this curve with respect to this line y is equals to x will be the graph of y is equals to log x at base a, because this and this are inverse of each other. Everybody got it? Everybody understood it? Yes or no? Same thing would have happened, sir, if the base has been, let's say, if the base has been, this is your y-axis and x-axis, that's clearly your straight line y is equals to x, let's say, for a while. So here, if you ever see a graph like this, then what does it mean? This is the graph of y is equals to a to the power x, where the base a lies between 0 to 1. Yes or no, everyone? So the same thing would have happened here. If you wish to draw the inverse of it, it would have gone like this. This is how you draw the curve log x at base a, where again the base a lies between 0 and 1. Getting it, everyone? What I'm trying to clearly highlight here is a very crucial and a very important fact, that if you ever wish to draw the graph of a to the power x, so if the base is greater than 1, then I hope everybody noticing that is clearly an increasing function. But if the base is less than 1, it is clearly a decreasing function. What does it mean? This means something really interesting here, which says that if you ever see 0.3 to the power x greater than 0.3 to the power y, look at the base. The base is 0.3. So if the base is 0.3, which is less than 1, so if the function is decreasing, for a greater value, there must have been a lesser output. For a lesser value, there must have been a greater output. Are you able to process my language, everyone? So will I not say that in this case, the sign will swap? The conclusion is pretty simple. The moment you notice the base to be less than 1, you simply swap the sign. Getting my point? Similarly, if I ask you 5 to the power x, something very basic, simple and easy, 5 to the power x is less than 5 to the power y. So there you need not hesitate in saying that x and y will follow the same relation because a to the power x is clearly an increasing function. Which means if 5 to the power x is less than 5 to the power y, x will also be less than y because 5 as a base is greater than 1. The same logic gets followed for logarithmic function as well. I'll come to that, but before I come to that, let's solve a question. A very beautiful, interesting, insightful, and an amazing question. What does it say? It asks you to find out the domain of this function. So two things I need to take care of. First thing, whatever is the expression inside that under root sign has to be non-negative. So first thing here is that, sir, 1 minus 5 to the power x divided by 7 to the power minus x minus 7 has to be non-negative. And second conclusion, sir, that this denominator can never be 0. Getting it, everyone? So one more thing I'll keep in mind is, from here only it will come into picture technically, but still if I wish to keep it written separately, I'll take it like this, that, sir, this whole thing is giving you one more thing to be kept in mind is that this thing, the denominator over here, which is 7 to the power minus x minus 7, this cannot be 0. So let's see where does it become 0, and we'll exclude that point. Let's see when does it become 0, right? Let's figure it out. So I hope you're realizing 7 to the power minus x is equals to 7 to the power 1. What does it mean? It means if base are same, which is 7 constant, powers can be equated or compared. So minus x is 1, which means x is minus 1. Which means I hope everybody is realizing this cannot be 0, this cannot be done, then this cannot be done. So technically, I will reach to a conclusion that whatever my answer is going to be, I will ensure that I don't take the value of x as minus 1 in my domain. Because the moment x becomes minus 1, 7 to the power minus of minus 1 is 7. 7 minus 7 will make the denominator become 0. Getting my point, everyone? Yes or no, all the participants? With this, what do we do, sir? With this, we come to, again, a very interesting conclusion that let's talk about this part. What do we do here? So let me try and simplify this. Sir, this part, if you wish to solve, instead of trying to apply wavy curve method, what I'll suggest you to do is, you want this expression to be positive, although equal to 0 is also fine. And when will it be equal to 0? Equal to 0, it will be in only one case. That also I'll discuss here. If I wish to make it equal to 0, it will be equal to 0 when 1 minus 5 to the power x is 0, which means 5 to the power x is 1. And I hope 1 without any hesitation can be written as 5 to the power 0. So I can conclude that x will be 0. So that value I'll take without any hesitation or problem. With this, having said that, now I will, instead of using wavy curve, apply some basics of maths. What do they say? Sir, something upon something needs to be kept positive. Because 0 we have ensured, it will be 0 when x is 0. So that condition I'm not considering. I'm solving it for keeping it to be positive. So imagine this. Something upon something is positive. When does that happen? So it will happen only when either both of them are positive or both of them are negative. Yes or no, all the participants. So sir, if I wish to make both of them positive, so two cases will get arised here. Two cases will happen here. First case, when both of them are positive. What is happening? First case, when both of them are positive. So I'll say 1 minus 5 to the power x to be positive and 7 to the power minus x minus 7 has to be positive. Or the second case, yes or no, students? So what about the second case? The second case, which I'll write here, will be this, where both of them are negative. So both of them are negative means 1 minus 5 to the power x is negative and this 7 to the power minus x minus 7 is also negative. So if both of them are negative, the ratio will be positive. If both of them are positive, the ratio will be positive. Yes or no, everybody? Getting it, everyone? Any confusion so far? Shall I move ahead from here? So let me try and solve the first case first. So there we go. 1 minus 5 to the power x needs to be kept positive. So I'll say 1 is greater than 5 to the power x. So 5 to the power x is less than 1. And here if I solve it, 7 to the power minus x is greater than 7, as we have just discussed. If you are not able to process this one, can I write this 1 as 5 to the power 0? So what does it say? It gives you a very important conclusion. Base is 5 greater than 1. So if the base is 5 which is greater than 1, I can equate the powers just the way they are. So this conclusion says x has to be negative. And this conclusion says base are 7 greater than 1. So I can just equate or compare the powers. So this conclusion says minus x has to be greater than 1. Which means if I multiply both the sides by minus sign, the sign of the inequality swaps. So this says x will be less than minus 1. Everybody understood it, or shall I repeat it? What did I just do? I said if minus x is greater than 1, if I multiply it by minus sign on both the sides, x will be less than minus 1. Yes or no? Now, if I wish to take the intersection here, what will I say? Sir, intersection says x less than 0, x less than minus 1. What's the intersection? Intersection, I hope, is very well understood by you all. Sir, x less than minus 1 will be common to both of them. That's my first part saying to me. Getting it, everyone, without any confusion? Or means what? Union. So that answer clubbed with this answer will be my answer. But what does it say? I think it will be just opposite of that, because signs have changed. So you can do it with that intuition only, that it will ultimately give you x greater than 0 and x greater than minus 1. If you don't believe me, let me solve it for you, but you really don't have to. This part, if I solve it again, 1 less than 5 to the power x. This 1 I can write as 5 to the power 0. Base is again greater than 1. Powers can be equated. So this says x is greater than 0. And here, 7 to the power minus x is less than 7 to the power minus 1. 7 to the power 1. So this says base is greater than 1. Powers can be equated just like that. So I'll say minus x will be less than 1. So again, will I not say that minus sign, if I multiply on both the sides, x will be greater than minus 1. So that gives you another conclusion. X will be greater than minus 1. It is and here. And means you put intersection, common you take. It says x is greater than minus 1. It says x is greater than 0. Common will be what? Greater than 0. So this says x is greater than 0. In a better language, I'll say x is from 0 to infinity. What's my final conclusion? My final conclusion is that that part said less than minus 1. This part says greater than 0. So finally, if I wish to conclude the domain, x will be either less than what? Minus 1, yes, or greater than 0. So greater than 0 means like this. That's your final answer. How many of you got it? I think somebody wrote it in the comments. I did not notice. Great, great. That's brilliant. If you're genuinely doing it without any, cheating AI or something like that, it's brilliant. Keep it up. Have you all understood it? Have you all gotten it? Have you all noticed it? With this logarithmic function, if I define for more clarity, if I try to bring logarithmic function into picture for more clarity, they also follow the same philosophy. They also follow the same logic. This is how you draw log x when the base is greater than 1. This is how you draw the log x when base is between 0 to 1. What did I just say, students? I said this is the graph of y is equals to log x at base a when the base is greater than 1. This is the graph of y is equals to log x at base a when the base is between 0 and 1. Everybody got it? Now, I hope you are very, 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 very clearly noticing that they are increasing and decreasing respectively when a is greater than 1 and a is between 0 to 1. I hope you understand increasing and decreasing means if this is x1, this is x2, then I hope I need not tell you log of x1 will be less than log of x2 because x1 is less than x2. Why did it happen? Because base was greater than 1. So if the base is greater than 1, the sign which gets followed between log x2 and log x1, the same sign will get followed between x1 and x2 because it is strictly increasing. Getting it, everyone? Similarly here, since it is decreasing, let's say this is x1, this is x2. I hope you are realizing x1 is less than x2. But in this case, log x1 will be greater than log x2. Sir, why did it happen? Because log x at base a, when the base is between 0 to 1, is a decreasing function. Able to get my point? Able to process my point? What did I just say? I said, let's say I'm told log m greater than log n at base a. So there I get two conclusions, two cases. Which two cases? Sir, I'll say m greater than n as long as a is greater than 1. But I'll say m less than n as long as a is between 0 to 1. Getting my point? Any confusion? Are you able to process this idea? And if you're able to process this idea, you will be seeing questions based on that logic and you'll be seeing them getting solved. These are some standard properties of logarithm which you have already studied in 11th, but for the sake of doing it, because some of you keep on claiming that's why we have wasted our 11th, we are doing it. Pay attention, everyone. The first property is something very basic. Log of, let's say, 2, base 10 or e, whatever you take, plus log of 3. So if the base are same on both the log, then I'll say it as log mn. Log m plus log n is log mn, which is 2 into 3, log 6. Everybody knows that. Yes or no? Very basic, direct and straightforward. Similarly, if I ask you log 10 minus log 2 at the same base. In mathematics, if the base is not mentioned, we prefer it keeping as e, Napier's constant. Then log m minus log n, we write as log m upon n. So log m upon n is given by log 10 by 2, which is log 5. Something very basic, direct and easy. But if I ask you, let's say log 8, so you may end up writing it as log 2 cube. 3 you can bring front and you can write it as 3 log 2. The property is that if you are given log m to the power p, you can write it as p log m. Another very crucial conclusion goes like this, where if you are ever encountering something like this, give me a moment, everyone. I'll just remove it. If you are ever given something like this, let's say log of 10 at base 8. So I could, if needed, write it as log 10 at base 2 cube. So if the base is raised to a certain power, then this 3 will come to the front, but as it's reciprocal, so I'll write it as log 10 as base 2. Everybody got it? Yes or no? So lovebirds are playing in the comments. You keep playing in the comments, but I won't be able to read your comments because I am in a very sincere mode to get something really crucial done. So I'm just blocking you both from my end so that I don't see your comments unnecessarily. But you keep chatting. We don't have any issues with that. You use this platform for your personal purpose, but let me get done with my job. Will that be okay? Coming back to this, I think these all we have done. Something very crucial I wish to discuss with you is that let's say in case if I wish to change the base, let's say this is log 3 base 2. I want the base to be 3. So what will I do in that case? I can swap this 3 and 2, taking its reciprocal. So I can write it as 1 by log 2 at base 3. Will you remember that? Some very basic direct formula and result I'm sharing here. Just to keep this thing in mind that here log p base a I'm given. Let's say log 10 base 5 I'm given. But no, for the sake of solving this question, I want this at base 2, let's say, for a while. So what will I do? I'll take this log 10 in the numerator. I'll take this log 5 in the denominator. And now I can put whichever base, whatever base I want here. Let's say if I wanted the base 2, I'll take the base 2 just like that. And I think these properties I have already explained, but one very crucial property we are still missing. Pay attention, everyone. IIT JEE asks a lot of questions on this every year. Very subtly and very indirectly, they use it in JEE Mains and Advanced questions. The property goes like this: a to the power log b base c. So, mind you, students, this a is a base which is raised to this power, log b base c. I'm not giving you the proof at this stage since it is the one shot, but I'm telling you a direct conclusion that this a and b can be interchanged and this expression still remains same. Which means if I swap this b and a, then b as a base raised to the power log a base c will also give you the same result. Everybody got my point? It has its own corollary. What is that corollary? Let me talk about that result as well. Let me talk about that very important and crucial result as well. If I try and tell you that corollary here, let's say if I'm told 5 to the power log, let's say 6 at base 5. So by using this property, what can I say? Sir, this 6 and 5 can be interchanged. So if I interchange this 6 and 5, I'll say 6 to the power log of this 5 at base 5. And as we know that log of something at the same base is always 1, ensuring that base is fulfilling that condition. So log 5 base 5 is 1. So answer is 6. So my suggestion to you all is that if you ever see this value and this value to be same, then unhesitatingly write this value as your answer. Understanding this, and this is very widely, prominently, and repeatedly used in JEE Mains and Advanced as questions. I'm giving you the direct result, and I'm hoping that you will remember that. Shall we try some questions on this idea, this thought, this process? Shall we, everyone? Here we have a question. It says, find the domain and range of the following functions. Let me begin with the domain part. So I'll do the first question. Second question, I'll be hoping and expecting that you do by yourself. Shall I? Here we are. It says log of sin x. How do we find its domain? Everyone, how do we find its domain? I'll say log. What does log say? So if I look at the graph of log, log says whatever input, whatever argument you pass to it, it has to stay greater than 0. So this part says that log is having an input sin x and it should stay positive. Yes or no? Although we know for sin x, one thing we very clearly know that it stays between -1 and 1. -1 to 0 I'll not keep, but I know that sin x cannot go greater than 0. That result I'll use later to find the range. But right now, let's talk about the domain. So I wish to ensure that sin x stays positive. Okay. So to give you the general result, I'll use the simple approach where I'll tell you that let's use the graphical approach because that will give you a better idea to visualize this, to imagine this. So graphical approach says that if you draw the graph of sin x, it goes like this. Now plot the points. A very beautiful, interesting thing you'll see. You could have drawn it on the negative side as well, but it will not confuse you unnecessarily. It will just, complicate it unnecessarily. So I'm just doing for the right-hand side part. So 0, pi, 2 pi, 3 pi, and 4 pi. This is how you see the points to be, yes or no? Now, what do we want, sir? We want sin x to be positive. Yes, we want sin x to be positive. So where do you see it to be positive? Sir, we are seeing sin x to be positive between 0 to pi, then 2 pi to 3 pi, then 4 pi to 5 pi. So what have we noticed? What have we noticed? What have we concluded? I think we are reaching to a very interesting conclusion that, sir, if you take 0 to pi, 2 pi to 3 pi, 4 pi to 5 pi, then it stays positive. What is the pattern here? The pattern is 0, 2 pi, 2 pi to 3 pi. So even multiple of pi to odd multiple of pi, even multiple of pi to odd multiple of pi. Are you noticing something? With this, can I not say that, sir, x belongs to an even multiple of pi to an next odd multiple of pi? Sir, are these points 0, pi, 2 pi, 3 pi, 4 pi, are they included? No. Why? Because at these points, it is becoming 0. And if sin x becomes 0, log of sin x will go not defined. So I'll ensure that sin x stays positive specifically. So I will not include these points. And I'm taking union, 0 to pi, union, 2 pi to 3 pi, union, 4 pi to 5 pi, union. So union can also be written in a generalized manner like this, where I know n is any integer value. So first of all, did you all understand and realize how did I find the domain? Has everyone gotten it? Has everyone understood it? Shall I move ahead from here, all the participants? And if you have been able to process the domain, let's talk about the range, which is even more interesting. So how do we find the range? Range is a very interesting part here. Let's say if I'm given sin x. We already know that sin x I cannot keep negative. Rather, I'll say not even 0. So I'll ensure that sin x stays positive. Beautiful. Excellent, Ankit. Moving ahead from here, I know one more thing, that sin x will be less than 1. Sir, up to an extent, can we keep sin x as 1? I hope no worries with that. Sin x maximum value is 1. Here, please pay attention, everyone. If log base is taken as e, can I take log's base as e? If you don't get my point, let me try and help you with the graph of log x. So this is how you draw the graph of log x. Yes or no? So on the graph of log x, you notice this is the point 0, this is the point 1. So if you notice or trace the graph of log x, if you trace the graph of log x from 0 to 1, the output gets like this from minus infinity to 0. Understanding my statement, everyone? Which means what? Which means that if sin x is between 0 to 1, ln of sin x. I can write log of sin x at base e as ln as well. So ln of sin x will lie between ln of 1, because it is strictly increasing. Ln of 1 is 0, and ln of 0 technically does not exist, but if it approaches 0, this ln of 0 will approach minus infinity. So it will lie between minus infinity to 0. What? The function. So domain, I hope we have clearly predicted. Range, if I wish to talk about, it will be minus infinity to 0, where 0 is clearly included because 1 is included. Everybody got it? Similarly, will you try the next question by yourself, all the participants who are watching it sincerely? Again, what will you do here? You will try to work out this quadratic, its domain, its range, and by having so, you can crack this question. I'm sure you would do it. You would be able to. With this, let's understand the next kind of function, which is even more interesting, which is called GIF, greatest integer function. What does it tell you? I was explaining this to the 11th class students today, and I was struggling a lot because they were not in the mood to digest it. They were taking it as a process of rounding off. I'm sure you all, being 12th class aspirants, would be able to digest and understand that there is a difference between rounding off and GIF. GIF as a function, first of all, it will be mentioned specifically in the question that this parenthesis sign represents GIF. Now, what does the definition say? The definition says that if you are taking GIF of a number, then look for all the numbers on the number line which are equal to or less than this number, which are integers. So 2.3, first of all, is not an integer, but less than 2.3 are 2, 1, 0, and so on. They are all the integers. So among all these integers, which one is the greatest? Sir, among all these integers, the greatest one is 2. So GIF of 2.3 is going to be 2. Everyone able to process it? Everyone able to digest it? Yes or no? In this manner, if I ever ask you one more very important and crucial fact, that let's say if I ask you what will be the GIF of 7.8, let's follow the same modus operandi here. What is the modus operandi? Let's say we have a number 7.8. Let's plot it on the number line. So there with 7.8, tell me what is going to be the integer which is either less than or equal to this 7.8. Sir, less than 7.8, there are a lot of integers. Among them, which is the greatest? 7.8 is not an integer. So just less than 7.8, which I see or notice are 7, 6, 5, and a lot more. So including this 7.8, if it is an integer, which one is greatest? 7.8 is not an integer, but among them, less than or equal to, greatest one is 7. So here, GIF of 7.8 is going to be 7. I think, sir, it makes complete sense. So if I ask you GIF of 0.98, what will you say? What is going to be the GIF of 0.98 according to you? Sir, again, if you plot it on the number scale, 0.98 could be somewhere here. So just on the left of it, there will be 0, -1, and so on. 0.98 is, of course, not an integer. So with this, just less than this or equal to this, an integer, if I try to find out, a lot of integers there are, but among them, the greatest one is 0. So 0.98's GIF will be 0. Everyone able to get it, or is it still confusing? For example, if I take 7, if I take just 7, I hope nobody is thinking that its GIF is 6. No, please understand. Let's follow the definition. Less than or equal to 7, there are integers 7, 6, 5, and all. Among them, which one is the greatest? Now, among them, the greatest is 7. It's not 6. So GIF of 7 will be 7. I hope it's very simple, straightforward, and direct. For example, if I ask you what will be the GIF of -6.2, again, if you plot it on the number scale, -6.2 will be somewhere here. -6.2. Let's not be beggars over here. I have never seen somebody begging like this. Come on. 6 6.2 we have written over here. So tell me, is it an integer? Of course not. But tell me integers which are either less than or equal to -6.2. So -6.2, I hope you're realizing -6 would be somewhere here. Negative number line it is. So I'll see -7, -8, and so on. So including -6.2, first of all, -6.2 is not an integer, but including -6.2, all of the integers which are either less than or equal to this, -6.2 is not, but -7, -8, -9, they all are integers. Among them, which one is greatest? Sir, among them, the greatest is -7. So GIF of -6.2 will be -7. Is it still confusing, students? Are you able to process it? Yes or no? Come on. Everyone able to process it, yes or no? What if I ask you GIF of -2.3? Is your brain clearly not telling you answer will be -3? Don't say -2 now. If you are habitual of taking just the integral part. I hope everybody understands this. If I ask you GIF of -5, it will be simply -5 because it is an integer now. Able to get it, yes or no? Yes or no? So if you are able to understand GIF, and if I could try and draw its plot, it is called step function as well, because it behaves as stair as well. It's a graph. When you look at it, behaves as stair as well. Sir, why do we call it step function? Let me demonstrate it for you all. Everyone, please pay attention. If I take values between 0 to 1, if I take values between 0 to 1, their GIF will be 0, 0.1, 0.2, 0.3, 0.9, their GIF will be 0. But the moment I take 1, its GIF will be 1, 1.1, 1.2, 1.3, 1.9, their GIF will be 1. But at 2, it will be 2. So 2, 2.1, 2.2, 2.3, 2.9 will have their GIF as 2. But then 3, 3.1, 3.2, and so on will have their GIF as 3. Yes or no? Yes or no? Definitely, definitely. With this, I repeat, -1 to 0 are what? -0.9, -0.8, -0.7 till -0.1. Their GIF will be -1. But when you look at 0, the GIF of 0 is 0. So I hope you, first of all, are able to make some sense out of its graph. If I ask you a few general, standard, basic questions, can you help me with its domain? So if you look at GIF function, and if you ask us its domain, so its domain means what? All the possible inputs which you can pass. So I think, sir, I'll without any hesitation be able to put all the values between -infinity to infinity, yes or no? I can try all the values. So if I can try all the values from -infinity to infinity, its domain is going to be all the real numbers. What about its range, students? Can you help me with its range? So range, if you look at, is more interesting here, that if you trace the curve, if you trace the graph on the y-axis, I'll be getting output as integral values only. The output which we are receiving is the integral values only. The outputs which we are receiving are the integral values only. Are you noticing it? Sir, I'm not getting any output between -2 and -3, -1 and -2, 0 and -1, and so on. Yes or no? So with this, what conclusion do I reach to? We reach to another very important conclusion, that its range will conclude all the integers only, the set of all the integers. Got it, everyone? Everyone comfortable with the GIF function? Yes or no? Yes or no? Yes or no? Now, something very crucial on which IIT JEE, not in relations and functions, but at a lot of other places, will ask you questions like this. More importantly, we'll be using this property in limits, continuity, and differentiability, where I'll be using sandwich theorem, squeeze theorem. There, I'll be using this result a lot. What did I just say? I said that GIF of any number you take, 2.3, let's say, is x. So GIF of any number will always lie between that number and that number -1. And there is a basic, valid, straightforward reason behind that. What is the reason? 2.3's GIF is 2. I'm just demonstrating it with an example, but I hope you are clearly able to process this idea, even with negative numbers, integers, or even 0 or positive numbers, whichever number you take. I hope you are able to process this idea completely. Yes or no? I am requesting you and humbly requesting you to memorize, learn, and remember this result, this particular result. This one will be using at a lot of places. Please. Can I move ahead from here? Then the next one, these two are solely an extension of this result. Let's say if I ask you a very basic idea, what do you mean by 2.3 plus -2.3 is GIF? And what do you mean by GIF of 5 and GIF of -5? what do we get? Sir, it's very evident. For 2.3, GIF will be 2. For minus 2.3, GIF will be minus 3. And its final outcome will be minus 1. But here in this case, GIF of 5 is 5. GIF of minus 5 is minus 5. And that sum is 0. That's exactly what these two results are clearly mentioning here. That if GIF of minus x and x is added, both individual GIFs, then it will be 0 if x is an integer, as you must have noticed. But if it is not an integer, the sum will be minus 1. Whenever I notice something like this, I'll not hesitate in replacing it by 0 or 1 if I know what value x holds. Not just that, while solving questions, I may create two cases where I'll consider x as an integer, x as not an integer, and I'll solve it. And ultimately, I'll verify my answer. Whether it is satisfying that or not, I'll do a question for you, don't worry. Very soon I'm going to bring a question for you. Now this conclusion I'll explain with example. Let's say if I ever ask you, GIF of x is greater than 3. GIF of x is greater than 3. Now here, let's imagine number line. So we have 3, we have 4, we have 5, and so on. Yes or no? Now you tell me what numbers can I take so that their GIF stays greater than 3. Imagine this by yourself. Sir, can I take 3.1? GIF of 3.1 will be 3. And I need the numbers such that they are greater than 3. So I think 3.9 also I cannot take because GIF of 3.9 will be still 3. 3 greater than 3, false. So what do I conclude? Sir, can I take x as 4? Of course. Because if I take x as 4, GIF of 4 will be 4, 4 greater than 3. 4.1, GIF of 4.1 is 4, 4 greater than 3. So if I take any number greater than equal to 4, my job will be done. So instead of learning results or memorizing results, if you are understanding them logically, it makes complete sense, yes or no? With this, shall I ask one more question to you? What if I want GIFX to be less than equal to minus 2? How will you produce the outcome? Will you not say that, sir, again, let's plot the number line. Let's imagine some numbers like, let's say 0, minus 1, minus 2, minus 3, minus 4, and so on. Now you tell me, sir, you want minus 2 to be there? Yes. Can I take minus 1? Of course not. Sir, why? Because minus 1's GIF is minus 1. Minus 1 is not less than equal to minus 2. False. Can I take minus 1.1? Check it once again. Sir, if I take minus 1.1, minus 1.1's GIF is minus 2. And minus 2 less than, no, but equal to minus 2, yes. So minus 1.1 I can take, which means I can take any value less than minus 1. So what does it conclude? It concludes x has to be less than minus 1. Sir, are you sure about it? Indeed, very sure. As in movie Mahendra Singh Dhoni, you must have heard this dialogue, as sure as I'm hitting a century in the next match. That kind of sure I am. I am saying if you take x as minus 2, minus 2.1, minus 3, whatever value of x you take, their GIFs are going to be less than minus 2. Yes or no? So I repeat, instead of memorizing the conclusions, if you simply remember the approaches, the idea, the modus operandi which I suggested, that will be more beneficial. Yes or no? Everybody comfortably able to process it? Yes or no? With this, let's try a question and let's get more clarity on this concept. Shall we? Everyone, please pay attention. The question here says the domain of this function. So we need to find the domain of this function. This function has this expression where this parenthesis represents GIF. One thing we know very clearly, sir, that domain means what? Domain means here it is a rational expression. Numerator is very well sorted 1, but denominator has something in x, and I know if there is something there in the denominator that I cannot afford to be kept as 0. Getting it, everyone? So denominator I'll avoid taking as 0, which means in order to find the domain, I'll say GIF of x square minus 7 times GIF of x minus 8 need not be 0. It cannot be afforded to keep 0. Getting it, everyone? With this, it looks like a quadratic where GIF of x can be treated as t for the sake of simplicity, but you all are IIT JEE aspirants. There I'll avoid asking you to do it. Just go ahead with this. Splitting the middle term. We want the product to be minus 8, but sum should be minus 7. Can I take it as minus 8 plus 1? I think yes. That will do the job. So I'll take it as GIF of x square minus 8 times GIF of x plus GIF of x minus 8 should not be 0. Had it been simply a quadratic equation, I would have said the roots are going to be 8 and minus 1. Remember that process? But here it is not equal to, it's not advanced level. Absolutely not advanced level. 3 lines question it is. Don't even call it mains level. So there I'll say GIF of x cannot be 8 nor it can be minus 1. Getting it, everyone? Yes or no? This conclusion, have you all been able to understand? If it is a quadratic, x is either 8 or minus 1, but it is GIF of x, a quadratic in GIF of x. So I'll say GIF of x cannot be 8 or minus 1. Now, what I do next is my final part. What does it say? It says, now let's again apply logic. Let's not mug up or rot any formula. Let's think logically. I don't want GIF of x to be 8. I don't want GIF of x to be 8. So if I take any number between 8 and 9, if I take any number between 8 and 9, including 8, 8.1, 8.2, 8.3, 8.9, so their GIF is going to be 8. So this part says x cannot be any number from 8 to 9. Because if x is taken any number between 8 to 9, 8.1, 8.2, 8.3, their GIF will be 8. So this part is very well understood by you. And along with this, I hope either this or this should happen, yes or no. This part says GIF of x cannot be minus 1. So if you have minus 2 here, minus 1 here, and 0 here, you help me with this. GIF of x cannot be minus 1. Definitely not. If you want to solve JEE advanced problems, you need to develop more better understanding. First of all, let's solve JEE mains problems, and with that, you will be able to solve JEE advanced as well. We always suggest that one-shots are never sufficient for JEE mains and advanced. Then, sir, why are you teaching us through one-shots? Because your generation is obsessed with one-shots. Okay, sir, we got your point. But I'll still say, in order to revise theory, in order to learn a concept, if you have missed the chapter and if you are intelligent enough to comprehend it through one shot, you should watch it. But sir, after watching that single one shot, will I be able to crack JEE Advanced? Sincerest apologies for disappointing you, but I'll say a simple thing here. After watching the one shot, if you have understood the chapter or the concept, a very huge, a very intensive practice is expected from your end. So start with JEE Mains PYQs. Last 5 to 6 years PYQs, 2020 onwards, JEE Mains PYQs you should solve. And once you have started feeling confident with mains PYQs, shift to advanced PYQs. And there, solve last 26 years PYQs, at least 2000 onward PYQs of JEE Advanced. With this, trust me, you will be able to get something really decent out of this chapter or any chapter, if you just keep following it with utmost sincerity. I hope I'm talking to the point, not making you feel good, but just telling you the facts. Now, however you wish to take it, that's your choice. I want a number taken in such a manner that its GIF is not minus 1. Sir, if its GIF is not minus 1, 0, I think GIF is 0. But minus 0.1, minus 0.2, minus 0.3 until minus 0.9 and so on, if I take before minus 1, their GIF will be minus 1. Even minus 1, if I take its GIF will be minus 1. So these numbers over here, if you take them, their GIF will be minus 1. What does it mean? I cannot take x as any number between minus 1 to 0. Is this the domain? No. Opposite of it will be the domain. This is what it cannot be. So what it can be, let's work on that. Definitely, you should. You're intelligent enough to conclude it. Very good. So here, conclusion of this gives you what? Sir, x cannot be 8 to 9. So I'll say, let me take or talk about this part negative first. I'll say x can be any value from minus infinity. Minus 1 is included here from exclusion. What does it mean? It means minus 1 I cannot take. I hope you're understanding it. So I'll say minus infinity to minus 1. Then minus 1 to 0 gets skipped. Yes or no? Union. Listen to me very, very, very carefully. One of the methods is you can write this answer as r minus 8 to 9 minus 1 to 0. One of the ways to write this answer will be r minus this set, which is minus 1 to 0 or 8 to 9. This is perfectly an acceptable answer. But let's say if it is not given in the options, then another way of writing is minus infinity to minus 1. Then minus 1 to 0 you simply skip. But 0 to 8 you take, and then 8 to 9 you skip, and then 9 to infinity you take. That's the domain of this question, or this function to be more specific. Everybody understood it, everybody got it. It is not JEE advanced level question, trust me. But yes, a simple, decent, straightforward question. If you are able to understand it, you will be getting it comfortably. Everybody able to process it? Any confusion? Now, shall we now talk about fraction part function? Fractional part function, if I could move ahead, I'll first of all make you understand this. Then gradually, I'll talk about its graph. GIF, I'm sure everyone is comfortable with. Just give me 2 minutes. Let me have water, then we'll resume. 2 minutes, everyone. Look at the way people comment. Come on. This is not how you beg. This is not how you beg. Anyways, let me just... Okay, moving ahead with this. Fractional part function we'll be talking about. Everyone, please pay attention. Fraction part function, unless it is not specified, unless if it is specified, I'll not take it as fraction part. So if GIF was expressed as a parenthesis, fraction part reserves the sign curly brackets. So for fraction part, how we write it? Let's say if I'm asking you fraction part of 2.1. So each number has a GIF and its fraction part. What did I just say? I am saying that let's say if I ever see a number x, then each number in the world can be written as the sum of its GIF and its fraction part. For example, let's say if I write 2.3. So 2.3 can be written as its GIF plus fraction part of 2.3. So what do you mean by this? This means GIF of 2.3 is 2. If I bring this 2 on the left hand side, it will be 2.3 minus 2. That will be the fraction part of 2.3. 2.3 minus 2 is 0.3. So fraction part of 2.3 will be 0.3. So that's easy. That's very easy. 0.3, that's answer. Great. You know it. You have cracked it. Let's check it one more time. Let's say I am now taking minus 2.3. So what the theoretical concept says, that any number in this world can be expressed as a sum of its GIF and its fraction part. So GIF of minus 2.3 plus fraction part of minus 2.3 will give me the number minus 2.3. Minus 2.3 stays like that, but GIF of minus 2.3 is minus 3. Remember that. Minus 3, if I bring on the left hand side, will be plus 3. That's fraction part of minus 2.3. Yes or no? And 3 minus 2.3 is 0.7. So fraction part of minus 2.3 is unfortunately not 0.3, it's 0.7. In logarithm, you must have understood the concept of characteristic and mantissa. It actually behaves like somewhat like that. Here, what did I just say? Pay attention, everyone. I am trying to tell you a very crucial concept. If you were able to crack whatever I've said so far, I am saying that if you are given something like this, 5.9, and tell me its fraction part, you should say 0.9. If I say minus 5.9, then its fraction part will not be 0.9, its fraction part will be 0.1. Getting it, everyone? Understanding the logic. For example, Let's say if I'm asking you 3.8, what will be its fraction part? Of course, 0.8. But for minus 3.8, you will say its fraction part will be, simply look at it like this. What should be added in 3.8 to make it 4? Understanding my point? To take it towards minus 4, how much more should be, delivered to it? So I'll say 0.2, sir. 0.2. Getting it, everyone? Didn't get it? Let me explain it from another perspective. This is minus 3.8 as a number. And minus 3.8's GIF is minus 4. So distance-wise, how much distance do I need to cover? 0.2. That's the fraction part. Able to get it, or shall I repeat it? Are you able to get it, or is it still confusing? Let me take a few more examples so that you are able to process it totally. 5.6, let's say if I'm asking you GIF. So imagine this. There is a number 5.6, its GIF is 5. The distance between 5.6 and 5 is 0.6. That's the fraction part. Got my point? Let's say if I take you through a number minus 10.3. Can you help me with its fraction part? You imagine minus 10.3 on the number line. On the left of it, there will be minus 11, and it will be the GIF of minus 10.3. Minus 10.3's GIF is minus 11. Distance-wise, what is the distance? So distance is 0.7. Fraction part will be 0.7. Is it still confusing? Is it still confusing? Does it make some sense now? Are you able to get it? If I ask you 0.3, what's the fraction part? 0.3. Getting it, everyone? But if I ask you minus 0.3, the fraction part will not be 0.3. Fraction part will be 0.7. Very soon. I think we have just told you this. The example covers everything. Yes or no? With this, if I try and show you the graph of fraction part function, So for 2.1, let's say if I wish to figure out, how will I do it? Sir, fraction part can be given by the number minus its GIF. That's what I'm telling you constantly. So 2.1 is 2.1. 2.1's GIF is 2. So it is 2.1 minus 2. That's 0.1. For example, if I ever ask you minus 2.6, what will be its GIF? You simply write the number. Sorry, fraction part of minus 2.6, if I ever ask you, you simply write the number and then subtract its GIF. What did I just say? Minus 2.6 stays like that as a number, but GIF of minus 2.6 is not minus 2, it's not minus 1, it's minus 3. Remember that? So this gets subtracted. So minus of minus 3 will be plus 3. 3 minus 2.6, that's clearly 0.4, and that's the fraction part. Shall I tell you, or has everyone understood fraction part? Has everyone noticed something very beautiful? That's our fraction part function is staying between 0 and 1. It is not going above 1 or below 0, not even 1. What did I just say? I said something very interesting and amazing and beautiful here, that if you have this as the y-axis and this as the x-axis, let's say, then in that case, if you wish to draw the curve GIF of x, then its graph will simply keep going like this. Its graph will simply keep going like this. Its graph will simply keep going like this. How and why? Let me try and tell you this. Pay attention, everyone. 0, this point over here will be 1. Let's say this is 1. So between 0 and 1, 0.1, 0.1, 0.2's fraction part, 0.2, fraction part of 0.3, 0.3, fraction part of 0.7, 0.7. So all the numbers between 0 to 1, they'll have their fraction part between 0 to 1, the same value. But 1, what is the fraction part of 1? Can somebody tell me what is the fraction part of 1? Sir, for 1, the fraction part of 1 will be 1 minus GIF of 1. GIF of 1 is 1, so 1 minus 1 is 0. Getting it, everyone? So our integers, the fraction part is 0 because there is no fraction in them. how will you be able to generate the fraction part? I repeat, let's say if I ask you the fraction part of -2. So fraction part is achieved by the number minus its GIF. Yes or no? Getting it, everyone? So -2 is like that only. This is minus. GIF of -2 is -2. So there will be +2. 2 minus 2 is again 0. So I hope you are understanding. For integral values, the GIF is 0. So -1 will have GIF. Sorry, 1 will have GIF 0. Similarly, if I reach at 2, so I repeat 1.1, 0.1, 1.2, 0.2, 1.3, fraction part will be 0.3. I hope you are processing it. So at 2, the fraction part of 2 will be again 0. 2.1, fraction part will be 0.1. 2.2, fraction part will be 0.2. 2.3, fraction part will be 0.3, and so on. So as soon as I reach 3, fraction part of 3 will be 0. It will not be 1. So are you understanding how are we drawing this as a function or as its graph? I hope no confusion regarding this and you are able to process all what is being said. No confusion, yes or no? So here if I ask you again the same question, what kind of function it is? Tell me its domain. What is going to be its domain? Can you say something about its domain? Sir, I can find the fraction part of any number between -infinity to infinity. I think I can take fraction part of any number, which means domain is going to be all the real numbers. But can you help me with the range? Can you help me with the range of this? The range, if you wish to talk about, range, which means tracing the curve on the y-axis. And if you notice it, no existence here, no existence here, but the graph exists specifically between 0 and 1. And to be more specific, 1 is not attained. Values between 0 to 1 is attained, including 0, excluding 1. Able to get my point, everyone? So with this, we reach to a conclusion that range will be any value between 0 to 1, where 0 included, 1 excluded. Getting my point comfortably, everyone? Able to process all what I've said so far comfortably, yes or no? So with this, I think you have learned a lot with the fraction part function. Let us talk about its periodicity. Do you not see or think or observe that it is clearly periodic? Sir, what do you mean by periodic? The same pattern getting repeated when I draw the graph, when I draw the curve or the graph, it keeps on getting repeated. The same pattern was repeating, which means what? Yes, it is discontinuous. Thank you so much, Rudraj. So I'll say this is periodic with the period t. It is a periodic function with the period t, period 1. Yes or no? Apart from that, I think that's clearly this fraction part function. So does it also have some properties? Yes. The first one, I wouldn't hesitate in saying that any number in this world can be written as a sum of its GIF and its fraction part. That's a very crucial and important result, which I'll ask you to remember, which I'll ask you to memorize. Please, will you all? I hope nobody would forget this. Okay, so shall I move ahead from here, all the participants? Here we are. As I have clearly told you that it is a periodic function, it follows a periodicity. What do you mean by a periodic function? Periodic functions means that let's say if 1.3, or if I do 2.3, or if I do 4.3, 3.3, 5.3, they all will give me the same output 0.3. So it is clearly a periodic function. Getting it, everyone? Yes or no, all the participants? With this, again, as we have discussed, two very important conclusions for GIF, the same kind of conclusions hold true for fraction part as well. Let me give you some examples. Can you help me with the fraction part of 2.3 and the fraction part of -2.3? What will it be? Sir, fraction part of 2.3 is 0.3. Fraction part of -2.3 is 0.7. So if you add both, it will be 1. Understanding the direct, clear observation. But if I ask you fraction part of 5 and fraction part of -5, so luckily, Fraction part of integers is 0. So this will also 0. This will also be 0. 0 plus 0 is 0. That's exactly what we are trying to give you. If x is an integer, fraction part of x and minus x, the sum will be 0 because x is an integer. But if x is not an integer, they'll be complementary in terms of 1. So if it is 0.3, it will be 0.7, and then when they are added, it will give me 1 as the outcome. Got my point, everyone? Understood it? Yes or no? Yes or no? All the participants. Everybody comfortably getting it? And if you have been understanding all what is said so far, let's try a question here. Let's try a very good, interesting, insightful question here. Shall we, everyone? Let's see how many of you get it. And if you are getting it, do write your answer in the comments. I'll be really happy and proud if you genuinely and sincerely do it without cheating, without using AI. Shall we try this question, everyone? What are we given here, or what are we told? It says find the domain and range of log of fraction part of x. This sign representing fraction part. This should be told in this question. Otherwise, I'll not take it. So what I'll say here is log of fraction part of x. Let's begin with the domain part. What does log say? So log says, if I go back to the graph of logarithm, log says log x, if base is not defined, I'll take the base as e, which is greater than 1. Log says whatever input you give me, whatever argument you give me, that input has to be positive. I hope you are seeing the existence of the graph only on the positive side of x-axis. Definitely. So does it not mean that this fraction part of x has to stay positive? Yes, sir, this has to stay positive. If this stays positive, sir, I think there is a problem. What problem? Sir, what I know from my intuition is that fraction part of any number lies between 0 and 1, as we have just seen in the graph as well, haven't we? Fraction part of any number lies between 0 and 1, but you want this fraction part to stay greater than 0. Of course, one conclusion I know is that fraction part it is, so it will anyways greater than equal to 0, but I want it to be greater than 0, and it will be less than 1 because that's the nature of fraction part of x. So my point is pretty simple here, students, pay attention. Fraction part of x lies between 0 to 1, including 0, but I cannot keep it 0 because it is passed as an input to log. Log says give me positive values only as an input. So I'll keep it between 0 to 1 like this. Have you all been able to process it? Yes or no? Yes or no? So I think there is no problem with this. Why? Sir, only one problem is there. Fraction part should not be 0. And when does it become 0? If you could not figure it out with your intuition, go back to the graph and tell me, sir, fraction part of x becomes 0 at all the integral points, minus 1, 0, 1, 2, 3. So are you all not realizing that, sir, I have no issues in keeping fraction part of x between 0 to 1, but I need to keep this thing in mind that x can be any real number except for integers. How many of you got this? How many of you were able to process this? How many of you understood the exclusion of all the integers? Let's say if I take 5. So I am saying log of fraction part of 5. Fraction part of 5 is 0. So you are saying log of 0. So log 0 is not defined. Log of anything, that anything has to stay positive. So I hope everybody is realizing for log of fraction part of x, x can be any real number except for integers. Are you all able to imagine it like this? Are you all able to think it like this? Sir, apart from that, can I take any value? Yes. Why can you not? Sir, can I really take minus 1.2? Yes. Because minus 1.2's fraction part you will be passing to log, where minus 1.2's fraction part is 0.8. So technically you are doing log of 0.8, and that's perfectly acceptable. Understanding it? So why are you I hope, why are we able to put the negative values as well? Yes or no? But sir, can we put integers? No, 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 no. Why? Because if I try integers, fraction part of integer is 0, and that's creating the whole problem here. I hope no confusion regarding this. With this, having said this, can I take it towards the range part as well? I think this only will give you the range as well. Look at this. Fraction part of x stays between 0 to 1 including 0, but it is passed as an input to log, so I'll avoid having it as equal to 0. So again, go back to the graph of log. Go back to the graph of log. Sir, you are saying keep it between 0 and 1, but 0 and 1 are not included. Yes, I'm saying this. So when input is passed between 0 to 1 to log, what output does it generate? It generates an output between minus infinity to 0. This point here will clearly be 1. So between 0 to 1, if an input is passed to logarithm, I hope you are clearly realizing minus infinity to 0 will be the outputs. Getting it or not, all the participants. With this, I'll say a very crystal clear idea here that if fraction part of x is between 0 to 1, to keep it defined, I'll say log of fraction part of x will stay between minus infinity. I hope you're realizing minus infinity to 0. So if you were believing that it was its domain, you have concluded the range as well, haven't you? What is range here, students? Can somebody tell me? Range here is going to be minus infinity to 0. Something through straightforward observation only you could have predicted or concluded. Great, great, beautiful, interesting. So I hope there is no confusion so far on whatever we have done, on whatever we have concluded, on whatever we have gotten. Yes or no, all the participants. Great. Moving ahead with this, shall we try a few more things? Signum function. When I was teaching this in my class, one of the students told Singham function. It's not Singham, it's Signum. Signum is again a very beautiful function. Let me try and explain this definition, then we'll come to this definition, shall we? So the definition here of Signum says that, sir, as long as x is not 0, Signum is given by mod x upon x. The moment x becomes 0, it becomes 0. That's how you create the piecewise function, the piecewise definition of this expression. It simply means, I hope you remember, if x is positive, mod x will be x, so x upon x will be 1. If x is negative, mod x will be minus x upon x will be minus 1. I'm really sorry I highlighted the wrong part, but I hope you're getting it. And the third part, if x is 0, the piecewise definition says it will be 0. Able to process it, able to digest it, or shall I repeat it? If I could try and tell you the graph will make more sense here. Here, graph says, if you are tracing the positive real numbers on the x-axis, all the numbers greater than 0, then the output is plus 1. Then the output is plus 1. If you are tracing all the negative numbers, which means all the numbers on the left of 0, then the output is minus 1. Then the output is minus 1. But the moment you jump at 0, the value is 0. So if x is negative, signum of x will be minus 1. If x is positive, signum of x will be plus 1. If x is 0, signum of 0 is 0. That's how you create the piecewise definition of signum. That's how the signum function is defined. First of all, tell me, is everyone able to understand signum function, yes or no? Can I move ahead from here? Everybody got it? Signum function, its nature, its behavior, its pattern. With the signum function defined, I hope we have the curve as well, we have the graph as well. Of course, for all the positive values of x, it is 1. Negative values of x, minus 1. At 0, it is 0. But signum is defined for other functions as well, which means signum of a function. Composition, if I do, there also it comes. If it is becoming confusing, let me take an example so that I can make it understood. Let's say I am willing to define signum of, let's say, log x or ln x. Look at this. It is very interesting. It is very interesting. Trust me. So Signum of ln x by very basic definition will be given by mod of ln x upon ln x as long as ln x is not 0. But the moment ln x becomes 0, it will be 0. Just following the basic definition. Sir, signum x was mod x upon x if x was not 0. And signum x was 0 if x was 0. But instead of x, the input here passed is ln x. So signum of ln x will be mod of ln x upon ln x as long as ln x is not 0. And it will be 0 if ln x is 0. I'm just extending the definition of signum. Everybody got it? Tell me honestly in the comments. Are you all able to process it? I'm not done with this. I'm just starting this. But if you're not doing this first step, confusion will get extended further. So tell me honestly, are you all getting it? Shall I continue further from here? Now, the next part says, let's simplify this. So signum of ln x, if I extend further, it gives me more clarifications. What clarifications? It is not even a question. It is an expression which I'm trying to teach you. How do we simplify signum of some other composition? Answer is 1. So, please pay attention. Ln x upon x. Sir, I wish to break it into 2 parts. Because mod it is. And if I wish to remove mod, I need to have more clarity whether the expression inside the mod is positive or negative. So I'll create or break it into 2 parts. First part, ln of x is not 0. So there are 2 cases. Ln of x could be either positive. Second case, ln of x could be either negative. Third case, ln of x could be 0. So I'll be giving you more better definition here. If ln of x is positive, you tell me, if ln of x is positive, mod gets removed just the way it is. So ln of x upon ln of x will give you 1. But if ln of x is negative, modulus gets removed and it opens with a negative sign. So negative of ln of x upon ln of x will give you -1 in this case. And we have just discussed, if ln of x is 0, it will be 0. Now, either you use your brain, intelligence, or use the graphical method. Both are fine. I'll teach you both the approaches. Some very basic, decent, standard result I'm trying to give you here. Based on observation, based on intuition only, based on basic idea only. So what are you saying? I am saying, look at the graph of log x. This is how you define graph of ln x. Yes or no? So I'm talking about 3 things, sir. Which 3 things? When do you see ln x to be negative? Let's talk about this part. When do you see ln x to be positive? Sir, ln x is positive. Ln x is positive. Ln x is positive in this part because this part is above the x-axis on the positive side of y-axis. So this point here is 1, 0. This is infinity. So I hope ln x is found to be positive for all the values of x which are greater than 1. Able to understand this? Able to digest whatever I've said so far? Or is it getting confusing? What did I just say? I said a very important, crucial result here, that signum of ln of x, if I wish to define, I'll say it will be 1 when ln x is positive. So ln x is found to be positive when x is from 1 to infinity. So I'll say here I'll take x greater than 1. Digesting it comfortably, everyone, without any confusion. Now the second conclusion. Sir, the second conclusion you were mentioning or saying that here you're wanting ln x to be negative. Ln x to be kept negative between -infinity and 0. That means lower than 0. That means on the negative side of the y-axis. So it is negative here like this. I hope you are clearly noticing the pattern, the curvature, that it is negative here below the x-axis here. For what values? Sir, for these values. Sir, what are these values? These are the values of x between 0 and 1. These are the values of x between 0 and 1. These are the values of x between 0 and 1. So if ln of x was needed to be kept negative, if ln of x was needed to be kept negative, the signum of ln of x is minus 1, but x in that case was kept between 0 to 1. Okay, sir, that also we have understood. Now let's talk about the third case. What is the third case? Third case says ln of x has to be 0. When do we see ln of x to be 0? So ln of x is found to be 0. That means intersecting the x-axis at 1, 1 comma 0. So if somebody says or asks that ensure ln of x is 0, so signum of ln will be 0 when, sir, when x is 1. Sir, if we don't want to do it with the help of graph, can we use it, solve it with the help of our intuition only? Do we really need to do it with the help of graph? Absolutely not. Absolutely not. The other way of doing it could be simple inequalities on logarithm if you know. Before I do it, log x is 0. So what is it? Let me simplify this. Let me simplify these results. This says log x at base e should be positive. Log x at base e should be negative. Log x at base e should be what? 0. So you help me in simplification. Log x at base e should be 0, which means e to the power 0 should be x. E to the power 0 is 1. So x should be e to the power 0, which means x should be 1. Everybody got it? Yes or no? If you don't get anything, use your basics. Go back to the basics. Here, this is 0. Can I write 0 as log 1 at base e? Can I write 0 as log 1 at base e? Even if you don't take anti-log, you can use your basics intuition here. E and E, base is same, greater than 1 because it is 2.7. So if the base is greater than 1, the relationship between x and 1 will be same. So if log x is less than log 1, x will be less than 1. So this concludes x will be less than 1. Log x greater than log 1, base is e, greater than 1, which is 2.7. So the same relation will follow, and I'll say here x will be greater than 1. Everybody comfortably got it. How did we create signum of ln of x? It will be 1, minus 1 and 0 for these values. Sir, how do we draw its graph? Yes, you can. Let's say if you are asked to draw its graph. I repeat, first of all, don't forget putting this scenario here that, sir, if you are saying x is between 0 to 1, don't forget to keep it between 0 to 1 because x is technically an input passed to log at base e. So the base cannot be, so this input, the argument cannot be negative or even 0. It has to be positive. So our graph will be defined between 0 to infinity only. But there will be a very crucial point 1. So how is it defined? Sir, between 0 to 1, signum of ln of x is minus 1. So let's say this point is minus 1. So the graph goes like this. Of course, at 0 it is not defined, a hollow circle. But at 1, it becomes 0. At 1, it becomes 0. So at 1, it will be going like this. Everybody processing it, understanding it? After 1, when x is greater than 1, it becomes 1. So there will be a point 1. And after x taking values greater than 1, it becomes 1. So that's how you draw the graph of signum of ln of x. Did you all get it, or shall I repeat it? Everyone processed it. Everyone comfortably understood it. Any confusion, query or concerns if you have, please ask. Otherwise, we'll move ahead with a question on JEE Mains, asked by JEE Mains in 2024. What does it say? Very beautiful, interesting, insightful, excellent, astonishing question. The range of this function for all x is between a to b closed interval, and alpha and beta are the arithmetic mean and geometric mean of a and b. Okay, then alpha by beta is going to be what? Let's solve it step by step. Let's solve it one step, another step, right? Let's do it. So if I move ahead with whatever I know so far, can you help me with this basic conclusion which we have developed? A cos theta plus b sin theta. Do you remember that general result which we have just discussed in the few slides back? A cos theta minus b sin theta always lies between under root over a square plus b square is negative, 2 under root over a square plus b square is positive. So here, tell me the denominator, this sine 3x plus cos 3x, does it not match with something very amazing you already know? Because 3x and 3x angles are same, I can apply this. So there, I'll say that if I wish to talk about sine 3x plus cos 3x by using the same property here, what will I say? Sir, coefficient of sine 3x is 1. Cos 3x also has a coefficient 1. So 1 square plus 1 square is 2. So this will be under root 2 with a negative sign. This will be plus root 2 with, of course, a positive sign. Any confusion so far? Everybody able to get it? Are you all there with me? Everyone. Sir, with this, denominator has 2 in it. So I'll add 2 to all the 3 sides. And I'm sure it does not change. It does not change the conclusion or relation so far at all. Any confusion? Now let me take you towards that reciprocal function so that you get more clarity on this. Here we are. Do you remember that reciprocal function? That reciprocal function behaves like this. Now can you help in plotting 2 minus root 2? Root 2 is 1.4. So 2 minus 1.4 is somewhere here. This is 2 minus root 2 and this is 2 plus root 2, let's say somewhat like this. So this will be 2 minus root 2, this will be 2 plus root 2. So 2 minus root 2's output will be 1 by 2 minus root 2. 2 plus root 2's output will be 1 by 2 plus root 2. What are you talking about, sir? I'm talking about the function y is equals to x. This is y is equals to 1 by x. This is x and this is y. Sir, what are you exactly saying? Although this is what you need not do as an IDJ aspirants, but I'm saying that here, let's say if the input is 2 minus root 2 to 2 plus root 2, then output is, I hope you're understanding, from 1 by 2 plus root 2 to 1 by 2 minus root 2. Are you getting it? If the input is this, both are positive. So output will also be this, the reciprocal of both positive values, but greater one becomes the smaller, smaller one becomes the greater because you're technically taking the reciprocal. Getting it or not, everyone? This is coming up with a very common conclusion, which we always keep on discussing, that if x is between 2 and 3, then we know 1 by x will be greater than 1 by 3 and it will be less than 1 by 2. That basic idea I'm following, because both of them are positive, I can just do it like that. But to make it understandable, I've just done that. With this coming here back to this question, I'll say that if I take reciprocal, since both of them are positive, the sign simply swaps. So I'll say 1 upon 2 plus sine 3x plus cos 3x will lie between reciprocal of this, which is 1 by 2 plus root 2, to reciprocal of this, which is 1 by 2 minus root 2. Any confusion so far? Tell me honestly. All the participants, are you all comfortably getting it? Yes or no? Story doesn't end here. The story starts here. The story actually begins here. Sir, why are you saying this? Because the question is not this technically. It's merely 10 or 20% of 30% of this question. Why, sir? Because now I have reached to the range of this expression fx. So I cracked the range of fx, which we have cracked as this 1 by 2 plus root 2 to 1 by 2 minus root 2. Everyone comfortably processing it? That's the range because this is your expression f of x. Then what do we do, sir, in that case? How do we proceed further? They told you the range is a comma b in closed interval. So if the range is a comma b, this value here, this value over here is your small a. This value over here is the small b. If you wish to simplify, you can through rationalization. So if I wish to simplify, I could have said 2 minus root 2 if I multiply. So it will be 4 minus 2, that's 2. So let me rationalize so that it will look a little better or it will be more confusing. Let me keep it like this. I'll do it ultimately. I am told alpha and beta are AM and GM. So alpha is arithmetic mean, beta is geometric mean. Let's say A, B have their arithmetic mean. How do we write arithmetic mean? Arithmetic mean of A and B is given by A plus B by 2. Geometric mean of A and B is given by AB product raised to the power 1 by 2. Remember that? Then what are they asking you? Alpha upon beta. So I hope you're getting it. This is alpha and this is beta. Forget this thing for a while. Let's work on alpha upon beta. Then we'll come back to this expression. Okay. So if I work on alpha upon beta for a while, let me work on alpha upon beta. So alpha upon beta will be, what is alpha, sir? A plus b by 2. A plus b by 2 whole divided by ab raised to the power 1 by 2. Everyone getting it? So if I simply do this, ab raised to the power 1 by 2 can be passed there. So can I directly write it like this? A plus b divided by 2, a b raised to the power 1 by 2 each, like this. So now if I do this, sir, what? If I separately divide this and this, 2 I'm keeping outside as 1 by 2. I hope you are okay with this. Now, if this a gets divided by a to the power 1 by 2, b to the power 1 by 2. So a to the power 1 by 2 by b to the power 1 by 2 I'm left with. So I'll write it as a by b whole raised to the power 1 by 2. There. If b separately gets divided by a to the power 1 by 2 into b to the power 1 by 2. So b to the power 1 by b to the power 1 by 2 leaves you with b to the power 1 by 2 in the numerator divided by a to the power 1 by 2. So this gives you b by a whole raised to the power 1 by 2. That's your expression. That's your more simplified version here. And that will be the answer. But sir, have you cracked a by b? I think I will finally require a by b or b by a, whatever it is. So let's try and crack a by b and b by a both. So I hope this is a, this is b. So what is going to be a by b? If I crack a by b and simplify this, its reciprocal will be b by a. So let me work on a by b. So a by b, I hope you're realizing 1 by 2 plus root 2 divided by 1 by 2 minus root 2 is a by b. So 2 minus root 2 goes to the numerator. So it is 2 minus root 2 by 2 plus root 2. One very basic thing which you can do is you can take root 2 common from the numerator and denominator. So when you do that, numerator will become root 2 minus 1. Denominator will become root 2 plus 1. Everyone noticing it? How did I do it? I took root 2 common. So it became root 2 minus 1. Root 2 when I took common from the denominator, it became root 2 plus 1. This is your a by b. Can you simplify it further? Yes, by rationalizing. So if I rationalize it, let me do it. Pay attention, everyone. Root 2 minus 1, if I multiply in the numerator and denominator, so this will get squared and I'll have root 2 minus 1 getting multiplied like this. So what happens in the denominator? So root 2 square is 2, 1 square is 1, 2 minus 1 is 1. So denominator stays sorted and root 2 minus 1 whole square will be what? I hope you know what to do with this. Root 2 minus 1 whole square. I'll not simplify this. I'll keep it like this. I will deliberately keep it like this. So a by b, I am getting as root 2 minus 1 whole square. I'm keeping it like this deliberately. I hope no confusion with this, everyone. And with this, can you not help me with b by a as well? Everybody, please pay attention, everyone. B by a, if you want here, can I just do it on the next page here? I'll directly write it, but if you want to understand it from the scratch, I'll do b by a as well. So if I do b by a here, let me do b by as well. Although you really don't have to, since you know a by b, but still if you want, you'll get more clarity with one more attempt. So b by a if I do, that will be this upon this. Are you understanding? This upon this. So it will be 2 plus root 2 upon 2 minus root 2. Again, when you take root 2 common, it will be root 2 plus 1 upon root 2 minus 1. Now again rationalize it. So what will you have? Sir, in the numerator, it will be root 2 plus 1 into, I'll multiply it by root 2 plus 1 in the numerator and denominator. So are you processing it? Root 2 plus 1 will get squared in the numerator. Root 2 plus 1 will get squared in the numerator. But root 2 minus 1 into root 2 plus 1 will be 2 minus 1. That's 1. So this will be b by a. So we have b by a as well as a by b. Yes or no? Yes or no? Now, can you help me with their square roots? Because ultimately, my answer contains a by b raised to the power 1 by 2, b by a raised to the power 1 by 2. So if I raise them to the powers 1 by 2. So if I take square roots of a by b and b by a. So square root of root 2 minus 1. Root 2 is 1.4. This is 1. 1.4 minus 1 approximately is 0.4. So I can take it directly like that. I need not put a mod over there. So it will be root 2 minus 1. That's root a by b. Getting it, everyone? What will be root b by a? So if I wish to figure out root b by a, so that will be square root of this. Root 2 plus 1 is positive. So that will be simply root 2 plus 1. I need not put a mod over it. So that's root b by a and root a by b. Technically root 2 plus 1 and root 2 minus 1. So If one of the values is root 2 plus 1, other values root 2 minus 1 are not taking care of the order. It could be either this or this. And finally, it's half needed to be taken. I think, sir, 1 and 1 needs to be cancelled. Root 2 plus root 2 is 2 root 2. 2 and 2 are cancelled. Your answer will be finally root 2, which is option D. Did you get it? 1 and 1 are cancelled. Root 2 to root 2. So 2 and 2 are cancelled. You're left with root 2. That's the answer. The moment I started solving a good question, the live watching dropped to 2, which is square of our answer. No ways. I get it. You don't like good things. No worries. It's YouTube ultimately. Great, great, great. It's really, really happy. I'm really happy to be a part of your journey. So now let's talk about even and odd. But let me have another 10 minutes break and then we'll talk about even and odd. And with that part, I think we'll be done. So final lab will do after this. With this, I'll begin. But let me take a break. So we are taking a break of 10 minutes. Will that be okay? So 10 minutes break. We'll resume at 10 o'clock. Thank you so much, everyone. So, hello, hi everyone. Just give me a quick response. I hope I'm clearly visible and audible. If you all can hear my voice, come back. If the system is still open, if the phone is there on the table and you're walking around, roaming around, hydrating yourself, relaxing yourself, or stretching, then come back, everyone. If you all can hear my voice, if you all can see me. Shall we get started, everyone? Shall we resume rather getting started? So with the final lap, we'll be done with a lot of things. Hello, hi everyone. Once again, shall we get started? This question we have already done. I'll say a very good, insightful, and an amazing question it was. Let's now discuss even and odd functions very quickly. Even and odd, if I wish to define, this function y is equals to x square is even function because even function follow a very simple definition that if f of minus x you receive as f of x, they are defined as even functions. Even functions follow a very important crucial property that when you notice their graphs, they're symmetrical with respect to the y-axis. Whatever portion you see on the right side of y-axis, the same portion you will notice on the left of y. Look at this curve, y is equals to mod x. So whether you take mod of minus x or mod of x, it is same. That's exactly the property of an even function. And if you notice its graph as well, y-axis is behaving as a mirror because the same portion is symmetrically getting placed on the negative side of x-axis as well in the same fashion. That's an even function for you. Everybody got it? Everybody understood it? Odd is also a very interesting function where if you are seeing passing input x as minus x gives you minus outside of f of x, then it is said to be an odd function. What does it mean? I hope you are clearly noticing that for an odd function, you will notice that with respect to origin, whatever portion you are seeing of the curve in first quadrant, the same portion symmetrically getting reflected in the third quadrant. So it is symmetrical with respect to origin in the opposite quadrants. For example, if you look at graph of sin x, the sin x here and the sin x here is clearly symmetrical with respect to the origin in first and third quadrant. Everybody got it? Everybody understood it? Now, this is a very beautiful, very interesting fact on which you will be seeing questions in IIT JEE. Every single function in this world can be represented as a sum of even and odd function. What does it mean? Let's say there is a function fx which is e to the power x. But sir, we want to express e to the power x as a sum of an even function and an odd function. Can we do it? Yes. To make it even and odd, I'll say fx should be added with f of minus x divided by 2. Without any hesitation, this function, if you notice, is an even function. Similarly, with fx, if I subtract its minus and if you divide it by 2, it will be an odd function. If you don't believe me, check it out by yourself. If you substitute x by minus x here, this will become e to the power minus x, e to the power x by 2. So it is again f of x only. Yes or no? So f of minus x turns out to be f of x. If you substitute x by minus x here in this case, it will be e to the power minus x, it will be e to the power plus x. But if I take negative sign common out, it will be minus of f of x only. That's my whole point, which I'm trying to make you understand here, that if there is a function, and I hope everybody is clearly realizing, e to the power minus x by 2, e to the power minus x by 2 when get cancelled, leaves you with e to the power x by 2, e to the power x by 2, and when they are added, it finally gives you e to the power x. So did you all understand that any function in this world can be represented as an even function and an odd function? Sir, why do we really need it? Are we going to use it in future? Yes. In questions, you definitely will. How? I'll show you with questions. But everybody understood this fact that any function in this world can be represented as a sum of an even part and an odd part. Comfortable with this? Shall I move ahead from here, all the participants? Any confusions, queries, or concerns? Can I move ahead from here? Did you all get it? Now, there are some more conclusions regarding even and odd. What are they? Let's cover up them one after another. If an odd function is continuous at 0, then without any hesitation, you can say f of 0 is 0. Continuity means what? Continuity clearly means, hold on for a while, there is some important notification coming up. Okay, great. So f of 0, f of x is a continuous function. F of x is a continuous function. So if f of x is a continuous function, an odd function. So if it is an odd function, for example, let's say this is how the graph goes. Same reflection I should see with respect to origin of this graph. So how will I draw it? I'm bad at drawing, but I hope it makes some sense. This is how this curve is symmetrical in first and third quadrant. And we are told that this curve is continuous at 0. So in order to ensure that it is odd as well as continuous at 0, how can I ensure it? So if it is continuous at 0, graph will exist. And if it is odd, which means symmetrical with respect to origin, with respect to opposite quadrants, so the only way to make it happen is that this curve will pass through 0, 0. That is the only way to make it happen. Which means if there is an odd function which is continuous, then it is bound to have f of 0 as 0. Will you remember it as a fact? One more thing, remember it as a fact. If even function is there and if it is continuous and differentiable, then also its derivative at 0 will be 0. We'll understand this as a fact when we study the chapter Limits, Continuity and Differentiability. There I'll cover it in a more proper manner. One thing through observation only, you all must have witnessed that all the even functions are many one. Why? Because they are going to be symmetrical with respect to y-axis. So if let's say this is the graph, then this will be the graph. And if you do the horizontal line test, it intersects the curve at two places or more than one place technically. So it is going to be even with this fact many one. Yes or no? Now one very interesting table I wish to show you, and I want to you all understand it logically. Sir, what do you mean by understanding it logically? Pay attention everyone. If there is a function fx, there is a function gx. If there is a function fx and gx, how do I remember it? If both fx and gx are even, then remember it, their sum or difference or product or division will be even. Even their composition will also be even. Getting it or not, everyone? Getting it or not, everyone? Shall I repeat it? Continuing further, look at the pattern. Look at the pattern. If both of the functions are even, their sum, difference, product or division or even their composition will stay even. Everybody got it? Everybody got it? Now, let me talk about both being odd first. So let's say fx and gx, there are two functions and both of them are odd. Both of them are odd. In that case, their sum or difference will be odd. But please understand this as a fact that odd into odd will become even. Please trust me, odd into odd. Imagine this, x cube and sin x. So that is also giving you a minus. This sin x is also giving you a minus. So minus minus will become plus. Odd you treat as minus, even you treat as plus. So minus into minus will be plus. So if you multiply two odd functions, you will get an even function. Able to understand the logic? The same follows with the division as well. Fx upon gx. So what is fx upon gx? Odd upon odd. Odd upon odd. Again, minus upon minus. Minus minus cancelled. You are left with plus. So odd upon odd will also be even. So odd into odd is even. Odd upon odd is also even. Getting it or not? Yes or no? Similarly, one more very interesting fact, odd of odd, composition will stay odd. If you don't get it, you can develop it. Let's say, sir, I'm not getting this one. Can we develop it? Yes. How? Let's learn it logically. Let's say I'm told fx is an odd function. So instead of writing it as odd, I'll say that I know fx and gx both are odd. So I'll say f of minus x is minus fx, that I know. I know g of minus x is minus of g of x, right? Now let's say I want to put my comment on fog. I want to put my comment on fog, f of g of x. I want to know whether it is even or odd. So how will I do it? Sir, I'll say, let's find f of g of minus x. So what we know is, sir, g is odd, it will pass out minus. So minus will get processed outside. So it will be f of minus of g of x, yes or no? F is also odd. So if you pass negative, it will pass it out. So it will leave me with minus of f of gx. Understood it? So that's how you can logically build it. You can imagine this whole process in your brain as well. So you really don't have to calculate or solve it like this. So the whole table can be learnt and understood with this simple idea. I'll give you some more conclusions. For example, here, let's say if an odd and even are added or subtracted, so it will be neither odd nor even. But please understand, if odd and even are multiplied, so imagine negative into positive, that is negative. Negative upon positive is also negative. One very beautiful fact I wish to highlight again, if composition of odd and even is done, it will be even. Because let's say this is odd, this will give me a negative output, but this f will consume it. Vice versa. If f is odd, g is even, so g will already consume that negative. So f of g will be again f of g. So if one of them is even, their composition will be even. Does it make some sense? Are you able to process it? Any confusions, queries or concerns on even and odd? Tell me honestly. Any doubts? Tell me. This question says you need to find out that here, this function given to you, there is a small correction. I think it is not 2. Let me just make a small correction here. This I don't think is 2. This I think is x square plus 1. I think so. It has to be x square plus 1. I think so. I'm not sure, but let me write it as x square. Then we'll explore it. So there is a small correction. It will be, I think, x square plus 1. Shall we try it now? So this question here says that this function fx is given as log of x plus x square plus 1 inside an inner root. Then this is an even, odd, or not even, or odd, or periodic. Periodic we'll discuss later, but if it is even or odd, how do we check it out? So sir, if you wish to verify whether it is even or odd, how will we do it? I'll say, this is f of x. Can you help me with f of minus x? Yes. What will be f of minus x? Sir, f of minus x will be log x gets replaced by minus x. So it will be minus x plus under root over x square plus 1. Everybody getting it? Yes or no? Yes or no, all the participants. Now, one thing I'll do here is very simple fact. Instead of writing it like this, even if I write it like this, are you okay with this? X square plus 1 minus x. Even if I do it, I hope you're okay with this. So I'm simplifying this. I'm not reaching to a conclusion yet. I'm just trying to simplify it because sometimes rationalizations give you some very, very important results. So here, denominator will be written as under root over x square plus 1 plus x. That's how you get the rationalization done. Conjugate of it gets multiplied in the numerator and denominator. So in the numerator, it gets multiplied by positive of this, conjugate of this. So a minus b into a plus b is a square minus b square. So a square will be x square plus 1. Under root over square is simply under root square will be nullifying it. So it will be left with this minus x square. This is what I'll be left with. Everybody got it? How did I rationalize this? After this rationalization, I hope everybody is noticing that, sir, x square and x square can be cancelled. Then, sir, what have you attained or achieved by doing this? Have patience. Let's explore it. So I'm still exploring f of minus x, which is given by log of. Everybody noticing that this can be written as 1 upon under root over x plus under root over x square plus 1. Let me reiterate it. 1 upon x plus under root over x square plus 1. Now, pay attention everyone. Here, if I take it in the numerator, this is 1 upon x kind of a thing. I can write it as x to the power minus 1. So here I can write it as, or log m upon n is log m minus log n. Log 1 will be 0. So I'll be writing it as negative of log of x plus under root over x square plus 1. Everybody got it? Everybody got it? And what is technically, this is f of minus x. Now what is it? This is minus, and what is this? This is clearly f of x. Yes or no? So f of minus x, we are reaching to a conclusion as minus of f of x. What does it mean? What does it mean? It clearly means that f of minus x is turning out as minus f of x. It is an odd function. Everybody got it? Any queries or confusions? Please ask if there are. Shall I move ahead from here? All the participants getting my point comfortably. Now with this, let us move towards periodic functions. I think periodic functions we have already discussed when we were talking about trigonometric functions. So I'll directly give you conclusions related to periodic functions. I hope you remember periodic functions we have discussed sine, cos, tan, sec, cosec, cot. Remember that? Even fraction part function we have discussed as a periodic function. So I'm sure you already understood why negative x is put. Natik, watch it from the beginning. You'll understand it. Don't worry. Coming back to the discussion here to check whether it is even or odd, right? Come back here. If I ask you the properties on even and odd, let's start discussing them. Few standard results, if you remember, questions based on function being periodic or not, or the periodicity, you can figure out very easily. How? Let's talk about that. So, sin x, cos x, sec x, and cos x, they are standard functions and their periods are clearly 2 pi. Please remember that. But if you talk about tan x and cot x, so period of tan x and cot x will be half of 2 pi, which is pi. These two conclusions you are mandatorily supposed to keep in your brain, no matter what. Now the next thing, fraction part of x, I hope you do remember, we have just discussed through its graph as well. Domain, range, everything we have discussed in detail. It is quickly a quick review of whatever we have done so far on periodic functions or periodicity. This here is given by 1. Now this thing, if sin x, cos x, sec x, and cosec x are raised to a certain power, then if the power is even, the period will become pi. If the power is odd, the period will become 2 pi. Everybody got it, or shall I repeat it? Participants, give me a quick response. Yes or no? Give me a quick response. There is an important call I'm receiving. Let me just respond to this. Otherwise, just give me a moment. Okay, so there we are. Everybody got it. I repeat, whatever I'm saying here is a very simple fact that let's say if you have sine x raised to the power 5 and sine x raised to the power 8. So both of them will be periodic. But if the power is odd, its period will still stay 2 pi. But if the power is even, its period will become pi. That's what my point is. Yeah, coming back to this, but even for 10x in cortex, whatever is the power, even or odd, the period still remains pi. Understanding, yes or no? But the power has to be a natural number. It's not about the fractional powers like 2 by 3 and all. Now, if you put modulus over sine, cos, tan, cosec, sec, and cos, whatever all these periodic functions are, then the period directly boils down to pi only. Remember this. Sine, cos, tan, cosec, sec, cot, for all of them, if you put modulus over them, the period becomes pi. Through graphical transformations, you can clearly understand this without any hesitation. With this, if I move further, constant function is also a periodic, but its fundamental period is not defined. How will you define it? Will you say its period is 1? What if I say its period is 0.5? If you say its period is 0.2, what if I say its period is 0.1? If you say its period is 0.05, I can say its period is 0.0001. So the logic remains pretty simple. Constant function is still a periodic, but its fundamental period cannot be defined. Everybody got it? Everybody understood it? Or shall I repeat it? One very crucial fact, which I'll be hoping you to remember is this, that here, if fx is told to be a periodic function, then whether you multiply fx by a, or you add fx to a, or if you subtract a from fx, or if you add a or subtract from x in this f of x, a being any real number, they'll also remain periodic with the same period t. What did I mean by that? I wish to say that here, let's say, if you are given sin x as a function, which we know has a period 2 pi, then please remember sin x plus 10, sin x plus 10, 10 times sin x. I hope you're getting it. Even I hope you're understanding. You create another composition of anything like that, they all will stay periodic with period 2 pi. One thing I have not covered yet, which is this third result, this one. Please look at this. Everybody, please look at this next result. This result is a very crucial one. If ever x gets multiplied with a number, if x gets multiplied with any number, of course, that number has to be non-zero. In that case, the period boils down to t by mod of it. Sir, what did you just say? I said, let's say if I ask you period of sine 5x plus 10 multiplied by 2 subtracted, let's say, 3 from it. So my whole point is simple, that this 2 will not change its period, this 10 will not change its period, this 3 will not change its period. Then what will? This 5 will. So sine x has a period 2 pi. Yes, sine x has a period 2 pi. So just divide its period 2 pi by the coefficient of x. Take mod as well. Don't forget to take mod. So mod of 5 is 5. This will be the period of 2 times sine 5x plus 10 minus 3. Everybody understood it? Everybody got it? Or shall I re-explain this part? All the participants, give me a quick response. With this, I'll be solving one of these questions. You tell me the answer to this. So this question I'm giving you as homework. You already know the answer to it. This one I'll be solving for you. So you tell me, will this 2 matter? No. Will this 6 matter? No. Will this 7 matter? No. This 5 matters. Cosec we know has a period 2 pi. But x is having a coefficient 5. So you're simply supposed to divide it by mod 5. So answer will be again, luckily, 2 pi by 5. This question, when you receive this PDF after this session, try it at home by yourself. You can get this PDF through our WhatsApp channel, and link to our WhatsApp channel is given in the description of this video. Now, these are the properties I think which we have already covered. You can revise them or go through them by yourself. Let's have a look at one of the questions. But before I tell you a very interesting fact, I'd like to discuss something really amazing. Let's say I wish to take LCM of pi by 3 and pi by 2. Can I take? Yes. So if you are dealing with fractions which has irrational terms in the numerator, rational terms in the denominator, their LCM of fractions are taken by any LCM of any fraction you can take by taking LCM of the numerators divided by HCF of the denominators. Everybody understanding this, or shall I repeat it? So there, LCM of pi and pi will be pi, and the HCF of 3 and 2 will be 1. Remember this? So here, if there are two functions, first function fx, which has a period t1, which let's say is pi by 3, for example. If there is another function, let's say gx, which is also periodic, which has a period t2, which has a period, let's say, pi by 2. Then combination of them, for example, fx plus gx or ff minus gx, will also be a periodic function, as we have just discussed. Unfortunately not, Harshit. Sincerest apologies for disappointing you on that front. Coming back to this, fx plus minus gx is going to be the LCM of t1 and t2. Remember this, if you are taking LCM of a rational with an irrational, it is mathematically not allowed. It is mathematically not allowed. So you cannot take LCM of a rational and irrational. No. So if I ask you to take LCM of pi by 2, and let's say even irrational of the same type you cannot take. For example, pi by 2 and 3, if I wish to take the LCM, you just cannot, because pi and 3 have nothing common between them. But let's say if I wish to take the LCM of let's say 2 pi and 3 pi, I can. The LCM will be 6 pi. But let's say if I want to take LCM of root 2 and root 3, I can, because root 2 and root 3 will give me root 6, which is divisible. But let's say if you are taking the LCM of pi and root 3, again you cannot. They are irrational of the same type. No, they are irrational of different type. That's a problem. Even if you wish to write, you can write it as root 3 pi. It's fine. This is also fine. Irrational and irrational, you can take it like this. It is perfectly fine. But if you are taking LCM of, let's say, pi and 3, that's not allowed. That's not allowed. That's clearly not allowed. Will you remember that? So irrational and irrational you can take. But this LCM, let's say, for example, 4 and 6, you can take because they both are rational. But LCM of rational and irrational, you cannot take. Will you remember that, all the participants? With this, let's consolidate all what we have learned so far with this simple, standard, decent, direct example. Shall we, everyone? Are you all there? Just give me a minute. Let me get done with my coffee and then we'll resume. Here we are. This question asks you, which of these is not periodic? So I'll say, let's see whether they are periodic or not. So sine 3x, sir, mod of sine x has a period pi, but it is multiplied here, 2x. So this will have a period pi by 3. Sir, sine square x, if sine x is raised to an even power, becomes or gets the period pi. So if they are added, their period will be LCM of pi by 3 and pi, and I think I can take the LCM because it will be LCM of pi comma pi divided by HCF of 1 comma 1. So I think it is clearly justified. It is periodic, but they are asking you non-periodic. So option 1 is not your answer. Option C, if asks you cos 4x. So cos x has a period 2 pi, but x gets multiplied by 4. So its period will be 2 pi by 4 pi by 2. 10, whether power odd is there or even is there, it always has a period pi. So this time here, the period of their addition or subtraction will be 2 pi by 4, which is pi by 2, comma pi. And I hope again we can take the LCM, because pi by 2 and pi by 1, we can take the LCM. But we are not very much interested in that. We are just interested in finding whether they are periodic or not. Look at this part, cos 2x. Cos x is periodic with 2 pi. So cos 2x will be periodic with 2 pi by 2. Sin x is periodic with 2 pi, period 2 pi. So pi and 2 pi, we can find the LCM. We can find the LCM very easily. Yes or no? Yes or no? So I think this is also periodic. So they are asking you non-periodic. Why? Because root x is creating the whole problem here. Root x is creating the whole problem here. So that's why it is not periodic. Composition, if I could explain, I'll explain it with a very simple, straightforward example. You'll get complete clarity. Let's say if I want to define a function fx as, let's say, sin x. And if I want to define another function gx as ln of x, log x at base e. Now, composition says g of f of x you are defining. So, g of f of x will say g of f of x. What is f of x? Sin x. Sir, g of x was ln x. So, g of sin x will be ln of sin x. Getting it, everyone? Sir, this is the outside in approach. Can we use inside approach? Yes. What do we want? We want g of f of x. So what is g of x? G of x is ln of x. So g of f of x will be ln of f of x. Getting it, everyone? And what is f of x? Sir, that's sin x. That will also give you ln of sin x. Everybody understood this result. Everybody comfortably got this result. Are you all getting it? First of all, what is the composite function? We'll try, Anirudh, and we'll try to bring it. Don't worry. We'll definitely try to. Don't worry. I'll have a word with the team, and if the demand really comes out, we'll definitely do it. Don't worry. You have my assurance. Someday we'll definitely. Before your exam, of course. So there, if I have something like this, composition, did you all understand? So how do they behave? Composite functions, if you wish to understand, you have an input that is passed as an input to a function or expression, and that output which you generate with this again gets passed to another function. Please pay attention, everyone. This here is your x is passed as an input to this function fx. You generate f of x here, and that input, that output which you generate with fx gets processed as an input to this another function gx, and this gx takes the input f of x. So finally the output which gets produced is g of f of x. Let me try and explain this. Let's say, what is x? X can be any real number, but that's the problem here. X, if you take any real number, sin x will produce all the numbers from -1 to 1. But can gx really take all the numbers from -1 to 1? Of course not. I repeat, I'll take you through this once again with an inverted manner, with an opposite manner. I repeat, look at this part only. The definition of g of f of x. What does it say? Sir, here you are taking ln of sin x. Yes or no? Yes or no? So log says whatever argument, whatever input you pass me, that has to be positive. So it says that sin x has to stay positive. And as we have just discussed in one of the questions, the same question, domain of log of sin x, there it clearly told me that if sin x is positive, we did discuss it with complete clarity. I hope you remember, sin x is positive, it means 0 and pi. Then I hope you remember 2 pi to 3 pi and so on. So I can take these inputs only. Which inputs? If I wish to pass on the inputs, I'll say I can pass the inputs from either 0 to pi, then 2 pi to 3 pi, then 4 pi to 5 pi, and so on, like this. I cannot pass an input from pi to 2 pi. Why, sir? Sine can take all the values, all the real numbers. Sine can take, but the output which sine will produce will be passed in as input to log, and log will not be able to accept those negative values. But if you pass values from 0 to pi, sin x will get values from 0 to 1. What is f of x? F of x is technically sin x. So if sin x is given, these values, 0 to pi, then pi to 2 pi, no. Then 2 pi to 4 pi, 3 pi, yes. Then 3 pi to 4 pi, no. But 4 pi to 5 pi, yes. If you pass on these values, 0 to pi, then 2 pi to 3 pi, then 4 pi to 5 pi. If you pass on these values, these values, there, sin x stays positive. So sin x will produce the outputs from -1 to 1? No. Sin x will produce the outputs from 0 to 1, where 0 is also excluded because I'm using open interval. And with these inputs, if I process them through gx, what is gx? Gx is ln of x. Remember that. So it is taking the input from 0 to 1. So log x, when takes the inputs from 0 to 1, I hope you remember, log x at base e accepts the inputs from 0 to 1, it produces the output. It produces the outputs from -infinity to 0. So it will give me the values from -infinity to 0. Everyone getting it, or are you still confused? So that's how you process the composite functions. Is it making some sense? Are you all able to process it? Are you all able to digest it? Yes or no? Composite functions. Yes or no? Everybody got it? Now let's understand some very crucial and important properties related to composition. The first one, where some people make mistakes. Composition is not commutative, which means fog and golf are not same. Someday, let's say you find f of g of x. And if you wish to say that, sir, g of f of x would also be in same, no, it cannot be, interchanged like that. So you just cannot take it. Everybody getting it on? But it is associative. Associative means whether I find fog first and then of h first, or whether I find g of h first and then f of g of h, it will generate the same result. So order, if you keep same, then whether you go with outside in approach or inside out approach, it will give you the same output. Getting my point, everyone? Similarly, composition of any function with the identity function is function itself. What did I just say? It's a very beautiful property. JEE Mains has asked a question on it. They gave you two functions, fx, which they gave as, let's say, ln x, and they give you gx, which was something, but ultimately when you solve it, it resulted into an identity function. And then you were given a question like f of g of g of g of g of g of g of x a lot many times like this. So there, what you all should have understood is that finally, after solving this, I'm just giving you an example. After solving it with a lot of steps, we concluded or reached to this from that question asked by JEE Mains that gx was x, which means gx was an identity function. So if a function is an identity function, no matter how many times you take its composite, it will give me the same output, same output, same output. So gx is x, then g of x will be x, 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 x. So ultimately that whole thing is getting combined or clubbed as x only, converging as x only. So ultimately this thing is nothing but f of x only, and it was this ln of x only. So composition of an identity function with any function is that original function. Getting it or not, all the participants, or shall I repeat it? Everybody understood that? With this, let's solve a very interesting and a good question here, shall we, everyone? Here it says that gx is given by 1 plus root x, f of gx, f of g of x is given by 3 plus 2 root x plus x. Then you are asked to figure out f of x. Okay, sir, let's do it. So to do it, let me do it like this. What are we given? F of g of x, right? This is f of g of x. So f of g of x. G of x is 1 plus root x. So can I substitute this result by 1 plus root x here like this? F of g of x. G of x is 1 plus root x. So I'm substituting that result here. Everybody getting it? Yes or no? Then it leaves you with 3 plus 2 root x plus x, because that's the RHS we are given. Yes or no? Now, to figure out f of x, I am interested in a very good thing here. For a while, this 1 plus root x, can I take as t? 1 plus root x, can I take as t? Yes or no? All the participants. With this, I'll be generating few more conclusions. What conclusions are? Root x will undoubtedly be t minus 1, and x will be t minus 1 whole raised to the power 2. Now, if I substitute these values, sir, 1 plus root x, you are asking it to be substituted by t? Yes. There, this 3 stays like that, 2 stays like that. Root x, I think we have cracked as t minus 1. So this root x, I'll substitute by t minus 1, plus this x, I'll substitute by t minus 1 whole square. Everyone getting it? So I think I'm very close to reaching to my conclusion or the answer, because here, if I simplify this, I'll get it. 3 plus, this will be 2t minus 2 plus, this will be t square plus 1 minus 2t. Yes or no? And that's f of t on the LHS. So there, t square stays like that. 2t and 2t are cancelled. And then 3 minus 2 is 1, 1 plus 1 is 2. So this is t square plus 2, which is f of t. So if f of t is t square plus 2, f of x will be x square plus 2. I think that was easy. But did you understand the SOP, the modus operandi? How do we deal with questions based on composite functions? How do we work it out? Everybody understood the whole idea? Let's solve one more question. It will give you more clarity, and it's a very good question. It's a very good question. This kind of questions you will be doing more in limits, continuity, and differentiability. In even AOD, application of derivatives. Sometimes with the differential equations, probably with area under the curve. Yes. Composition you'll have to deal a lot many times in the upcoming chapters. And this is the foundation which we are laying here with the relations and functions. Let's do it here. This says this is f of x, this is g of x. Then you need to define f of g of x. Okay, let's go ahead with this. F of g of x, how will it look like? Sir, f of g of x you want to create? Yes. So f of x, in place of x, if I create or write g of x, I think my job will be done. Yes. So this will be given by g of x plus 1 as long as g of x is negative. Getting it, everyone? Or it will be given by g of x squared. It will be given by g of x squared as long as g of x stays non-negative. Everybody understood this? All I did was nothing. I redefined f of x, but in terms of f of g of x. So in place of x, all those x, I just substituted them by g of x. Everybody getting it? Yes or no? All the participants. Okay, sir, understood. Then what we do is the next task. Pay attention, everyone. Here, the next thing which I'm going to do here is f of g of x, right? What we know about g of x is this. Look at this part. I'll try to talk about g of x separately first. Let me talk about g of x on a different page. Let me give you more clarity on g of x. What through my intuition, experience, and observation, I can say g of x is a very interesting function. Why am I saying this? Because if I notice the pattern of g of x, for x being less than 1 and for x being greater than or equal to 1, for x being less than 1, it is behaving as a cubic function. So this is x as 1, this is 0. So if this is the y-axis, x cube goes like this and then this. And at 1, it will be 1 like this. This is the graph of x cube. Getting it, everyone? Getting it, everyone? Yes or no? By my intuition only, I could conclude it like this. So between minus infinity to 1, gx will be drawn like this. Then what happens is at 1, it will be 1 into 2, 2, 2 minus 1 is 1. So at 1, it is continuous. So at 1, it will attain this value. And from here onward, it will be a straight line 2x minus 1. I hope you remember straight line y is equals to mx plus c. So with this slope is 2, positive, it will keep increasing. So it will be another straight line like this. So this is another part of gx, which is 2x minus 1 when x is taking values 1 onward. So this is how gx should make sense in your brain. This is how gx should make sense in your brain. Although you really don't need it, but to make this question more understandable, I'm doing it here so that you can make a lot of sense out of this question. Then if I bring this gx here, while creating f of g of x, you will be seeing a lot of good things coming out of this question. So what do you mean by that? Here, so this part says gx needs to be negative. Okay, so when are you seeing gx to be negative? Sir, gx being negative means this is gx. Gx being negative means that this part, we are talking about this part. Gx being negative means this part when your curve is below the x-axis. So gx being negative means what? Gx being negative means, sir, all the values of x which are from minus infinity to 0, gx is negative. Sir, the question says keep gx to be negative. Okay. So when gx is negative, use this definition. But where are you seeing gx to be negative? I am saying that I am noticing that gx is negative for all x between minus infinity to 0. I hope I'm not confusing anyone. So here I'm saying that gx is negative for all x between minus infinity to 0. So gx, pay attention everyone, the most crucial part. If you understood this, the job will be done. Here, this is the most critical part. If you got it, your job will be done. Just pay complete attention. Don't lose your focus now. Gx is giving me two portions here. Let me give you the complete definition first. This f of g of x when I created, where are we? I think this is where we are. It told me that your g of x will be separated into two cases. One case when gx is negative, second case when gx is non-negative. So when I look at the graph of g of x, sir, it gives you two conclusions. One case when gx is negative, that is happening between minus infinity to 0. Sir, gx is becoming positive. That means above the x-axis when the x is from 0 to infinity. Everybody getting it? The graph is going like this and then this. I hope there is no confusion on this front. Everybody getting it? Please pay attention, everyone. This is the most critical part of this question. If you could get it, your job is done. And in the future, whenever you get something like this, you will be able to deal with this very efficiently and effectively. So there it says, when gx is needed to be kept negative, I can talk about x as well. I'll say if gx is negative, x is from minus infinity to 0. If gx is needed to be kept negative, I will say x is from minus infinity to 0. So this part I'll remove. I'll say that when gx was supposed to be kept negative, I'll say x is also from minus infinity to 0, which in simpler language, I write x less than 0. Okay, sir. But when x is negative, sir, x negative means what? I want the definition of g of x when x is negative. Sir, I know the definition of gx when x is less than 1. So I want the definition of gx when x is negative. So if x is less than 1, x is less than 0 as well. Getting my point? So I will use this definition of gx when x is negative. Because if x is less than 1, that means x is negative. So when x is negative, I'll be replacing gx by x cube. Are you getting this? Are you getting this? So gx here will get replaced by x cube. That's the first part here. Everybody processed it. Everybody understood it. Yes or no? Yes or no? Comfortably getting it, everyone? Now, sir, the next part. What is the next part? Gx needs to be kept non-negative. Sir, gx is non-negative between 0 to infinity because gx is above the x-axis for all the values of x between 0 to infinity. So this part here, where you want gx to be non-negative, I could split it into this part that I'll say that it means x has to be greater than equal to 0. Getting it, everyone? Yes or no? Now here, please pay attention, everyone. X greater than equal to 0. X greater than equal to 0. X greater than equal to 0. Sir, if x is greater than equal to 0, there are two parts in it. Two parts in it. When x is greater than equal to 0, one definition says when x is greater than equal to 0 but less than 1, you will be using this definition. X greater than equal to 0 means one part I'll split, that where x is till 1, I'll use this definition. But the moment x passes 1, the moment x is greater than equal to 1, I will be using this definition. So this part here gets splitted into two parts where I'll say one case where x is greater than equal to 0 but less than 1. There also this definition g square x will come into picture. But there I'll split it as x greater than equal to 1 as well. Have you all been able to process? Why did I do it? Yes or no? Or shall I repeat it? Everybody got my point that why am I splitting it into these two relations? Now, when x is between 0 to 1, gx definition will be used as x cube. the definition of gx will be used as x cube. So this is x cube whole square. So this will be x cube whole square, which means x to the power 6. But please pay attention, everyone. When x is greater than equal to 1, when x is greater than equal to 1, the definition of gx will be 2x minus 1. When x is greater than equal to 1, the definition of gx will be 2x minus 1. So when x is greater than equal to 1, the definition of gx will be 2x minus 1. So it will be square of 2x minus 1. And you just need to simplify this. That's how you define f of g of x. Everybody got it? Everybody understood it? Yes or no? All the participants. Are you able to make some sense out of it? Inverse function, I think I have already explained. When I explained inverse trigonometric functions, I gave you a complete detail. How do we define inverse? Why is it necessary to keep it bijective? How do we do its bijection? Injection plus surjection, invertible it becomes. Inverse trigonometric functions, we did a discussion on that after trigonometric functions. There I did define inverse functions. That whole theory comes into picture, but we'll consolidate it with this question. Shall we, everyone? Let's do it. There we are. It says there is a set A, there is a set B. F is a function from A to B. A does not have 3, B does not have 1. Apart from that, all the real numbers are there. Defined by f of x as x minus 2 by x minus 3. Prove that f is invertible and find its inverse. The process of finding the inverse is really simple. Y we write as x minus 2 by x minus 3. I'll do a very simple process just to make you understand the process of taking inverse. X minus 3, if I multiply here, it will be xy minus 3y is equal to x minus 2. Then what I'll do here is x I'll bring here, 3y I'll take here. So x I'll bring here, 3y I'll take there. So it will be xy minus x, it will be 3y minus 2. Now if you take x common here, if you take x common from here, this will leave you with x times y minus 1, and this here will leave you with 3y minus 2. So if you write x, you will finally receive it as 3y minus 2 whole divided by y minus 1. So what does it mean? What does it imply? Here, when you wish to define an inverse of a function, x you replace by f inverse x, and y you replace by x. So this is 3x minus 2 by x minus 1. First of all, tell me, have you all gotten the process of finding the inverse of a function? Have you all understood the process of finding the inverse of a function? I think all of these properties I have already explained. I have already done. So this is also I have told you that if a function fx is there, a function f inverse is there. So they are clearly mirror images of each other with respect to the line y is equals to x. With a lot of examples, I have already shown you in this video only, in this one shot only, with inverse trigonometric functions and a lot. With this, let's solve one more question here and let's understand it with more clarity. I think this is the same question with one more extension, that here it says f is defined from this to this, where fx is this. I think this is exactly what we have done previously, but yes, an extended version it is. G is defined from R to R, and this is given by 2x minus 3. Cool. Then they're asking you to find sum of all the values of x, for which f inverse x plus g inverse x is 13 by 2. Okay. So my primary job is to find out f inverse x and g inverse x. To find f inverse x, let me try and find f inverse x first, then I'll try and find g inverse x. Is that okay? So let me work on f inverse x. So I'll write, I'm really sorry. I'll write y as x minus 2 by x minus 3. So this will give me, I hope we have just done this, xy minus 3y is equal to x minus 2. I think this is same. X I'll bring here, 3y I'll take there. So it will give me xy minus x is equal to 3y minus 2. Correct me if I'm wrong. X, if I take common, it will leave me with y minus 1. So x will be 3y minus 2 upon y minus 1. So with this, if I wish to write f inverse x, how will I write it? This will give me f inverse x as this x I'll write by f inverse x. This will leave me with 3x minus 2 whole divided by x minus 1. That's how you define f inverse x. Yes or no, everybody? I think g inverse x I can do here only. If g inverse x I wish to find, I'll write y is equals to 2x minus 3. So x will be y plus 3 by 2. Yes or no? Correct me if I'm wrong. So with this g inverse x, I'll be writing as x plus 3 by 2. Getting it, everyone? Now, what's the question? Can you believe this? This is a question asked by JEE Mains. So there, if I continue further, they asked you to find the value of, let me just remove this unnecessary part, which doesn't matter now. We have f inverse x and g inverse x, yes or no? They are telling you f inverse x plus g inverse x. So what is f inverse x? Sir, f inverse x is, something is wrong. Give me a moment. F inverse x is 3x. 3x minus 2 divided by x minus 1. And what is g inverse x? That is x plus 3 divided by 2, and they want it to be 13 by 2. They want it to be 13 by 2. Okay, so I think it's basically an algebraic expression which we know how to deal with. So if I take LCM, 2 into 3x minus 2, that's 6x minus 4 is equal to, plus x minus 1 into x plus 3 whole divided by 2 times x minus 1. So this 2 and this 2 will get cancelled and x minus will be passed to 13. So it will be 13 times x minus 1. Everybody understood the calculation I'm doing? We can be a little quicker with that. So this gives you 6x minus 4 here, plus this gives you with x square, then this is minus 3x. And am I making a mistake? Minus, sorry. 3x minus x. 3x minus x is plus 2x. And this is minus 3 is equal to 13x minus 13. Yes or no? Getting it, everyone? Then what am I now left with? I'll be left with a quadratic x square. Yes or no? Then 6 plus 2 is 8. 8 minus 13, I think is 5, but minus 5 it will be. So it will be minus 5x. Correct me if I'm wrong. Minus 4 minus 3 is minus 7 plus 13. 13 minus 7 plus 13 minus 7. That's, I think, plus 6. And you know how to solve this quadratic. It gives you two values. X will be 2 and 3. X will be 2 and 3. And if you write the answer as 5, let me cross check it. X will be 2 and 3. But what is x here? X is the output here. Output of fx and gx. Because it is passed as an input to f inverse and g inverse. So if this is the input of f inverse and g inverse, so it is the output of fx and gx. So is fx allowing you any input? No, sir. F is not allowing us 3. So this 3 will be discarded. Is G allowing me everything? Yes, sir. G is allowing every single input. So this 2 is not a problem. So my answer will be not 2, 3. My answer will be 2 only. Sum of all the values is not 5. If you marked C, I hope you're realizing how it plays with your brain. Very subtly, it checked whether you understand the part of domain and codomain or not. Inverse function. Domain becomes range, range becomes domain. If you got it, you must have cracked it. Very easy question, very simple question, but it was very subtly checking a very basic understanding where you would have finally concluded 2, 3 and you would have told that answer is 2 plus 3, 5. And that's where you would have made the mistake. Everyone understanding that? Everyone realizing it? With this final part, I'll be teaching probably functional equations. Let's say if in a question I am told there is a function which fulfills this property, f of x into f of y, which is f of x plus y. Then I'll not hesitate in taking f of x as a to the power x. Similarly, even if I say, or somebody gives me in the question that f of x is a function which fulfills this property, f of x upon f of y is f of x minus y, then I know that property gets fulfilled by this function only. So I'll again take f of x as a to the power x. If I am given in a question, instead of telling me that f of x is log x, they give it in a little different manner. Functional definition they use, they say it as either f of x plus f of y is f of xy. Imagine this: log x, log y, log xy. Or they may give it as f of x minus f of y is f of xy. Log m minus log n is log m upon n. So I hope you are realizing that the moment you see it, you will treat f of x as log x. Similarly, other functions are also there which will study with the time. Don't worry about sine inverse, cos inverse and everything. They'll understand with the time. But something very beautiful and crucial which IIT JEE every year asks is this one. They ask this result every year. Every single year they ask a question on it. They definitely ask a question on it. I'll give you an example with which I'll try and make you understand. With this question, how do they use it? A very beautiful, a very insightful question. Whenever you're given a definition like this, what definitions are? that f of x into f of 1 by x is f of x plus f of 1 by x. If f of x into f of 1 by x is f of x plus f of 1 by x, then you should not hesitate in taking f of x as 1 plus minus x to the power n. That's exactly what I've told you here. I have told you this part here very clearly that if you ever see f of x into f of 1 by x as f of x plus f of 1 by x, this property our function fulfills, then f of x will be 1 plus minus x to the power n. Everybody got it? Everybody understood this result, yes or no? So this part I can take. But they told you that f of x is a polynomial function and f of 4 is 65. I think one information is missing here. One part is missing here. I think they were saying f of x is a quadratic polynomial, degree 2 polynomial. I think that information is missing. That part they should have said. That information they should have said. So there is a small error in this question. Let me make that correction. F of x is a quadratic polynomial. They missed saying it, I think so, because otherwise will not be able to do it with one information. Whenever you are dealing with this, there is an ambiguity. What ambiguity is that I need to remove this plus minus sign. I mean, either it will be plus or minus, but how will I ensure it? And I need to know the value of n. So to get details on whether to use plus or minus or n, I need two inputs. So sir, there is a problem that I think plus minus I would be able to remove with this information, but how will I get rid of this n? So one more information should be given. That is missing here in this question. Apologies for that. But in IDJ, whenever you see this question or this category of functional definition, you will be giving two information. I mean two data set. With one data set, you will be cracking n. With another data set, you will be cracking either plus or minus. Able to process my statement. So the moment it says it is quadratic polynomial, I'll not hesitate in taking n as 2. So my fx will now, in a more better language, will be defined as 1 plus minus x square. Getting it, everyone? Yes or no? With this, one more conclusion we develop here is, sir, plus x square or minus x square? How do we reach to this conclusion? Plus x square or minus x square. So let's do it with f of 4. So what do we get with f of 4? 4 square is 16. 1 plus 16 or 1 minus 16. I think there is something missing here in this question. Some information. It's not quadratic. Some information is missing here in this question because one more fact I should have been told here. F of 4 is 65. Okay, let me try and do it. Let me try with this without keeping it as quadratic. Let's say this is 1 plus minus x to the power n. Let's not say it is quadratic. Let's remove that information. I think there is some doubt here. Let me do it without using that information because 65 is not getting adjusted there. First of all, tell me one thing here. If f of 4 is 65, can I get it with 1 minus x to the power n? Imagine this, if n is a natural number here, x to the power n, 4 to the power something will be something huge with the natural numbers getting increased. So 1 minus something will be negative number. But this f of 4 is 65, which is positive. So I'm sure I can remove this negative sign. I can first of all conclude that, sir, f of x will not be 1 plus minus, it will be just 1 plus x to the power n. Everybody got it? Because 65 is positive, so it will be plus. Because 1 plus only will give me something positive. 1 minus something very higher power, a natural number. Even with 4 to the power 1 only, I'll get 1 minus 4, which is minus 3. So minus it cannot take. It is supposed to take plus. Everybody processed it. With this, I am saying f of 4 is 65. So f of 4 is 65. F of 4 is 65. Getting it, everyone? So 65 minus 1 is 64, is 4 to the power n. And I think 4 cube is 64. Yes or no? 64 is 4 cube. So if the base are same, I can compare this n. So I have cracked n as well. And we have cracked as 3. So we have gotten both plus sign and n as 3. So our f of x in a better language will be given by 1 plus x to the power n, which is 3. Now what am I asked? F of 6 f of 6 will be 6 cube plus 1, that is 216 plus 1 is 217, and that's your answer to this question. Everybody understood this, or is there any confusion? Tell me honestly. Have you all gotten a decent clarity on this? Yes or no, everybody? Yes or no, everybody? Now, what's your homework? Your homework is, this is Relations and Functions Part 2. Before this, we have covered Part 1 as well. This is Part 2. So if you did not watch Part 1, go through it if you want to understand or get more clarity on this. Not just that, once you have gone through this one shot, you may have this assumption that you are done with this chapter. Please don't assume that. After doing this, after watching this whole one shot, solve PYQs. Begin with JEE Mains PYQs and then shift to JEE Advanced PYQs. Even if you are doing Mains PYQs after 2020 onward, that is also a better practice. But for JEE Advanced, you should do 2000 onwards. But first of all, get done with JEE Mains PYQs. Even if somebody is in 11th standard, can watch it, because I think I have tried covering it in a more detailed, sophisticated manner, which will make you understand this whole chapter thoroughly and completely. So shall we meet in the next class, where I'll bring you ITF, inverse trigonometric function, in this series. I'm sure you must have learned and enjoyed a lot. You must have gotten a lot of valuable inputs. Shall we call it a day, everyone? Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.